there is no right way to do this. And so for next year, we want to kind of crowdsource what should be the topic, because we want to always be in a topic that is not yet established. It's something that is to come. So having said that, it's good, and that's why our conclaves don't have hundreds, 200, 300 people. All people who have a like-minded focus on the topic that we are discussing. And so with that, let me hand you back to the computer and hope we will have a good exchange of ideas during the day. Thank you.
Thank you, Dr. Dewan. And the big picture, the purpose of iCIIT Conclave. To speak about the vision and the purpose behind today, I would warmly welcome the Group CEO of Informatics Group, a leader who is a rare combination of expertise spanning mathematics, applied statistics, and applied psychology, together with extensive leadership experience across the technology and service sectors. Ladies and gentlemen, please welcome Mr. Rohan Fernando.
Start to update my pictures. Good morning, everyone. Once again, it's a privilege to be here. People publish papers, present, and so on. So we were debating about, do we want to add one more? Yeah, which is already like 20 of them going on to keep the researchers busy. Then we debate more about, like, if we don't have it, what should we have to encourage research, and especially to be in line with iIIT vision of being current and industry relevant? How can we use our research focus in line with our vision as a company, as a group? That's why we came up with, actually name came afterwards. We said, like, let's have a forum that we get people who are actually doing work on a particular topic, which is more current, more on R&D terms rather than established. That's what he mentioned, like every year we ask our question, what should be the topic next year? Actual answer is we don't know. That's the true answer, because last year we asked the same question and we said, no, we are 12 months away from finding out. So honestly, we don't know next year's answer, right? So this year's topic was, came to life because now it is a current question, right? Yes, there's a big hype, and we want to ask actually the people who are doing work, what is working? What are the challenges? So that's why this forum is only by invitation. So if you are here, that because discussions and dialogues, and some of those teams are still working on those discussions and dialogues, and some of those teams are still working on those ones. So these are very much initiatives that will push forward. That's the real aim and the vision of this iIIT Conclave every year that we start. to get people more involved, applying what we discuss, and keep the discussion going. So I invite all of you to make connections, have those dialogues, and use this forum to move the dial forward. And once again, thank you iIIT team, thank you Dr. Ruan, and thank you all the invitees who are here. I'm sure it's going to be a very engaging and intellectual discussion. And special thanks to Dr. Ruan to keep this momentum going. It's easy for me to come up with a vision, like, and then hand it over to somebody like him. So every year he has the energy and vision to carry it forward. So all the best, guys, and please use the maximum, and please give us feedback how we can improve and do it even better next year. Thank you very much. All the best.
Okay, next up in the session, I was eagerly waiting for the keynote address. The title that immediately stands out, level to level, something's don't change. He's a graduate of Stanford University and has spent over 8 months at Facebook and Meta, working deep with large-scale learning and advertising engineering systems. Today, he works as a computer scientist, investor, and consultant. Across production skill in engineering, data infrastructure, internet and music. Video knowledge is relevant for exactly what this room needs to be. Without further ado, ladies and gentlemen, please a very warm welcome to our keynote speaker, Mr. Rohan Sengupta.
Can you all hear me? Especially at the back? All good? Okay, it's important that you can hear me at the back because I'm asking questions for people at the back. So if you don't want to answer questions, you should move forward. There are few seats. Okay, the first question is an easy one. Who here has a credit card? Guessing almost everyone has a credit card. Okay, who would like a higher credit limit on your credit cards? Okay, interesting. So I'm not going to sell you some financial scam or something like that. I'm not here to do that. But I am here to tell you about a startup that I'm helping out with. And I can't tell you too much about it because they're still in sort of stealth mode. But what they're trying to do is to kind of come up with a smart credit card where the credit limit changes depending on the behavior of the customer. So if you're doing making smart financial decisions, your limit will go up. If you're doing dumb things, your limit goes down. That was kind of the idea. So a friend of mine came up with this idea almost 2 years ago, and this is back in the US. And then he and a co-founder spent about almost 18 months doing research into the laws and kind of regulation around kind of finance. So if you are familiar with finance, has like a lot of regulation. Back in the US, I think they had to read about 20,000 pages of law to do it kind of properly. So they spent about 18 months learning about kind of regulation, and then they also spent a lot of time talking to about 200 customers. Anyone who does a startup, like it's not only about technology. If you're going to build a product, you have to spend a lot of time talking to people and understanding what they really need. So they did all that, and that was about 6 months ago. And then they came to a point where they decided, okay, I think we are ready to build a prototype. But they had a problem. So my friend and his co-founder are both from a finance background. And so they had no experience in building kind of real computer systems. But then they heard about this thing, which was new at the time, which we all know now, this thing of using AI to generate code. So they kind of spec'd out their ideas as best as they could, and they fed it into LLM. I think at the time it was whatever version of Claude that was available, and they came up with some code. And for this fairly complex system, they were able to build a prototype in about a week. So two finance guys who know nothing about coding were able to build that prototype for quite a complex system in about a week. Now that product hasn't launched as yet because after they build the prototype, there's a lot more work to do. They are spending time getting various permits and permissions and things like that. It will probably be about another year before this actually launches. So the reason I told you this story is not as an example of how awesome AI is to generate code, but to kind of show that what the timeline, the big picture looks like. So you got about 18 months of research, then this very short time, about a week writing code, and then maybe another 18 months of all the hard work that goes into putting this product in the real world, right? So what I want you to take away from that picture is if you look at technology, the technology is in the middle. So the technology starts in the middle and it ends in the middle, and it has always been like that. So you have a beginning, which humans have to do. So for example, coming up with what problem you need to solve, that's a human problem. Technology can't solve that problem. And then in the end, you need to validate the system. Okay, does the system actually solve the problem that I wanted to solve? That is also something that humans need to do. So this picture kind of technology, AI in particular, is in the middle and it's also middle to middle. And so humans need to take care of the two ends, right? So it's kind of like a sandwich with two very thick slices of bread. And then in the middle, you've got like a very thin slice of meat or maybe cheese if you're a vegetarian. But the two thick slices are what humans have to do, and technology only deals with something in the for the future. I want to share some thoughts on that. Okay, so what my friend did there, we call that vibe coding. Vibe is an interesting word. Does anyone know where that word comes from? So it kind of comes from vibration. Vibe is like a shortened form of vibration. So you might have heard of, like, say, a friend goes to a cafe or something like that, and they say, I like the vibe of the cafe, I like the vibe of the party, or like the vibe of the restaurant. So when they say, I like the vibe of the cafe, they're not talking about the food or the coffee. It's like the feeling you get when you walk in. So vibe coding is also like that. You don't tell the machine exactly what to do. You kind of give a feeling of what you want to do. So it's not precise, right? So okay, I like words. Another word I like is a word called complement. Has anyone here studied kind of pure maths at like a university level? Okay, few people. Okay, so actually everyone, you probably studied O-level maths, right? So in O-level maths, we learn this thing. If you, like me, if you studied in Sinhala, there's this thing called Anupuraka Kone. So the Anupuraka Kone of 30 degrees is 60 degrees because 30 plus 60 is 90. So in English, that angle is called a complementary angle. So in mathematics, you have a whole lot of different types of complements. You have additive complements, multiplicative complements, you have complements of sets, you have complements of angles, like I said. So complement kind of means that, well, you could say it's kind of the opposite. Complement of one thing is the opposite of it, but actually what it means is you put two things together and we say that they complement if they kind of complete the picture. So you might say, like, okay, if two people get married, they complement each other. That means like they are more than the sum of the parts, kind of thing, right? Okay. So why am I talking about complements? So I have a question for you all to think about. So you have vibe coding, and my question is, what is the complement of vibe coding? So let me break down what that means. So imagine you have, okay, so we know how to do vibe coding. What can we add to vibe coding that when you put those two things together, you get a complete software engineering system which is safe, it's accurate, it does what it needs to do, it is responsible for solving the problem, all those things. Kind of things that vibe coding doesn't have, right? Like we don't trust airline to write code the navigation system, right? We will not get on that plane, right? But so what can we add to write coding so that we can trust it, it'll do the right thing, it'll be efficient, all that kind of stuff, right? So think about that a little bit. I will come back to that later. In the meantime, I want to talk about a topic that I've been interested in for a long time. And those of you who are in industry will also be interested in that topic, which is the topic of interviews in software engineering organizations. Okay, so I've been doing interviews for almost 20 years. And with software engineers, usually you do a coding interview. So basically, if a candidate comes, you ask them an easy coding question, and then you ask a more difficult coding question and more difficult, and the better candidates will answer more questions, right? So that's how we've done coding interviews. More recently, I have stopped doing coding interviews. And I do something that I call a reverse coding interview. So I'll tell you what that is. So normally, when you do a coding interview, you have a whiteboard and you ask a candidate to write code, or you give them a laptop and say, okay, type out the code to solve, like, what is the square root or a binary tree search or whatever it is. So in a reverse coding interview, what I do is, I give them about 100 lines of AI-generated code. And then, okay, there are about 5 bugs in this code. Their job is to find the 5 bugs. So that is a reverse coding interview. So a weak candidate will take this, either a print or a screenshot or whatever it is, they will look at it very carefully, read every single line, and then look at me and say, no, I don't see any bugs. There are no bugs in this. So there's a reason for it. So when a human writes computer bugs, it's like a human baby with a stomach upset screaming, right? The bugs are very obvious. But when an AI-generated code has bugs, they're very subtle. It's like a kind of a con man. You know what a con man is, right? Like a confidence trickster. So they're dressed very nicely, they look very confident. You think they're the expert. So that's what AI bug looks like. So in human-generated code, you get things like syntax errors, you get runtime errors. In AI-generated code, there's no syntax error. It's nicely formatted. Very rarely you get a runtime error. All the errors are kind of logic errors. So a weak interview candidate will look at that code. It looks fine. They don't know what's wrong with it. And they'll say, okay, so is this a trick question? Okay, how does a strong candidate react to this? Like a strong interview candidate, someone who I want to give a strong hire and hire as soon as possible. So even before looking at this code, they will ask me a question, which is, what is this code supposed to do in the first place? Right? Because you need to start with that. And then I usually ask them, okay, what do you think? Have a look at the code and say, what do you think the code is supposed to do? And usually what a good candidate is going to tell me is, I think the code is supposed to do this, but it's actually doing something slightly different. And that's where the bugs come in. So you have the 5 logic bugs where the code is doing something slightly different to what it's supposed to do, and those are where the bugs come in. So that is how we kind of react to AI-generated code. The bugs are very subtle. There are no syntax errors. There are no runtime errors. They're all logic errors. And in order to identify a logic error, you need to be able to do 2 things. One is you need to know exactly what the problem you're trying to solve. 2, you need to have the confidence and the knowledge to look at code, some of it which is very complex, and see whether it actually solves the problem. So the reason I told you this, I told you about interviews is I wanted to come back to that question. What is the complement of vibe coding? So a strong interview candidate in my reverse coding interview shows 2 skills. One is to really understand the problem. That's one. 2 is to have the confidence and responsibility to say that the solution actually solves that problem. So to me, these 2 things can only be done by humans. AI can't do this because AI doesn't have opinion on what it is. And also, you can generate an AI code which will go through code and see whether it's correct or not, but still it can't take responsibility. right? When the plane crashes or the patient dies, you can't send Claude to jail. I mean, you can send like Sam Altman or Dennis Hassabis or Dario Amade to jail, but you can't send Claude to jail, right? Or Claude or ChatGPT to jail, right? So that's the answer for me. What the complement of vibe coding is. So if you have vibe coding, but you also have these two things, the ability to understand problems and the responsibility to check whether the solution actually solves that problem, then you have a complete, safe, accurate, efficient computer software engineering environment. So there's good news and bad news. So the good news is we finally found at least two things that humans can do but machines can't do. Right? So we are not completely useless, which is kind of good news. The bad news is, at least from my experience in industry, very few software engineers have those skills. And one reason I say that is it's probably because these are two skills that you learn on the job. So in most software engineering companies, maybe traditionally, about half the population are kind of new grads or maybe up to 2 years of experience. It's when you get to 3, 4, 5 years that you acquire this responsibility of really understanding problems and really taking responsibility for the code. And I think one reason for that is there hasn't been demand for these skills in the past, nor is there supply from kind of universities and so on, where students have these skills. And I'm not talking about kind of lower tier or middle tier universities, I'm talking about top tier universities as well. Back in March, I was at an event at the computer science department at Stanford University back in California. And it was mostly for undergrads. And I was talking to undergrads from the computer science department. So this was in March, and they are graduating this month. They're graduating in June. And only about 50%, only about half, had job offers. So this is the university which is ranked number 1 in the world for computer science, and only half the students had job offers. Just for comparison, if you rewind to last year, every undergraduate of the CS department at Stanford University had 2.5 jobs waiting for them. So this is like a 5x drop, right? So the top university, 5x drop. And the reason is obvious. When I joined Facebook, now Meta, I was 26, and I was one of the oldest people in the company. My sister works for Meta now, and there is no one in her office who is under the age of 30. Everyone is over the age of 30. And all the top software companies are not hiring anyone who has less than 3 to 5 years experience. Sometimes 3, maybe 5. So we have this problem in the industry where you have a career ladder and you broke on the bottom layers, right? So the question is, okay, it's fine if you're already on the ladder. If you're already a successful senior software engineer, things have never been good because thanks to AI, your productivity has multiplied by 5, 10x. But if you're a junior engineer, you can't get on that ladder, right? So sometimes you have countries, even in Sri Lanka, parts of Sri Lanka, where you have war and that wipes out the entire younger generation. Some die, some immigrate. So we have kind of like a lost generation problem because we have a generation of junior software engineers who can't get on the career ladder. So that's probably, for me as someone in the industry, that's the problem that kind of worries me the most. Like, how do we solve this problem? Maybe it will be solved in industry where they come up with some system where you have like longer internships or something where you can get people in the pipeline earlier, or it has to be solved in academia. I don't know what the actual solution is. Okay, so I'm going to take kind of a small detour at this point and talk about Sri Lanka. So everything that I said so far kind of applies globally. I want to share a couple of thoughts kind of related to Sri Lanka because Sri Lanka is kind of a special case. If you take kind of global tech hubs like Silicon Valley or Bangalore in India or Shenzhen in China, like the kind of cutting edge things are happening, it takes a while before Sri Lanka. So technology may take anything up to 6 months It also means that we have more time to react to that. So that's one thing. Second thing is the model that I mentioned at the beginning. Technology is in the middle. AI is also now has made the middle of sort of a commodity. So historically, Sri Lanka's software industry kind of grew out of business process outsourcing, and that's firmly in the middle. Right? So you have a customer, the customer gives you the requirements, you don't come up with the requirements. The customer gives the requirements, you build the system, and then you give the software and the intellectual property rights back to the customer. So Sri Lanka has traditionally been in the middle, which means that Sri Lanka is disproportionately at risk from AI because we have operated in the middle. So that's the second thing to keep in mind. The third point is maybe because we've been in the middle, or maybe kind of this is the culture. If you think of my friend's fintech startup, the things that's sort of a business problem. Then turning it into code is a technical problem, and then taking it out to people, again, it's like a sales, business, marketing problem. So traditionally, respect for the types of people who do the middle. So to talk about like the old kind of joke, like, okay, if in marriage proposals, doctors and engineers are at the top. Like if you're doing business, like you don't even get any proposals kind of thing, right? Maybe they have better ways of finding spouses. So that mindset needs to change because kind of suddenly people in the middle are being replaced by AI. I didn't actually mention this earlier, but so we know about how AI affects software engineering. AI is going to significantly affect the medical profession as well. So all these kind of benchmarks that we see, okay, Claude is better than this level of programmer and so on. All those numbers are much worse or better depending on how you look at it for doctors in things like diagnostics and things like that. I think the only space where doctors are safe is surgery. But with advances in robotics, that might also change. Things like diagnostics, AI is kind of significantly better. And current time. Example of via negativa, like the negative path. So I'm also going to leave with two negative questions. One is for the people in academia. So if you want that student in 10 years' time to look back and say, okay, it was a good idea doing this degree, what courses that you currently teach should you stop teaching? That's the question for people in academia. So the question for people in industry is, similarly, if you want that individual to look back and say, okay, it was a good idea for me to become a software engineer, what roles do you currently hire for which you should stop hiring, right? So whatever decision that you decide to take, like keep this in mind. So there's that spectrum. There's the beginning, which need to be done by humans. There's the middle, which is done by technology. And the technology is in the middle and ends in the middle. That has always been the case. And you have the end, which needs to be again done by humans. And so within this model, how would you answer those questions? Thank you. I think I can take some questions from the audience, right?
We will now open the floor for Q&A session.
Yeah.
Any questions, ladies and gentlemen?
The two skills that I mentioned. Yeah, so the first skill is identifying what the problem is. So that is basically an opinion, a human opinion. You could build an AI that kind of tries to validate, but again, like I said, you can't put the AI in real. You can only put a human in there. Right? So those are the two skills. Yeah.
I really liked your talk because you are talking about disruptive innovation, which Professor Christensen at Harvard, in fact, has written books on it. So very good for us to think of that, Innovation without disruption doesn't have we are negative.
Yeah.
And that's the problem I think we have in lots of places. So thank you.
Yeah. Thank you. Yeah.
Questions really. One is you said the beginning and the end is what the AI is not into.
Yes, humans are the beginning and the end. Yeah.
So one problem is probably at the front end, at the top end.
Yeah.
AI will start creeping in at some point.
You mean at the beginning?
At the beginning.
Yes. Yes.
That's one issue
Yeah.
that I see.
Yeah.
The second is I'm wondering whether we should reimagine this whole process of software development, saying forget about something called coding.
Yeah.
That might be a different approach.
Yeah.
Because eventually the machines will do it.
Yeah.
So
Yeah. Yeah.
what is it?
Yeah. So two really interesting comments. So I think. What's called a papal encyclic. I do personally is I don't look at feeds because someone else AI has basically decided kind of what to show me. Instead, I try to choose all the media that I kind of consume. I think if we are not mindful about that, we'll find that, okay, we have slowly turned into AIs and AIs kind of make all the decisions on our behalf. So really important comment. The second comment was like rethinking coding in the age of AI. So I was actually briefly discussing this with Dr. Ruan as well. So when we use AI to generate code in programming languages which are designed for humans to program, so like Python or JavaScript or C++, I think a very interesting problem for academics, especially in the programming language field, is to start designing programming languages that that have been specially designed for AIs to program in, and the converse. Okay, actually, a programming language is merely a way of communicating with machines. It doesn't have to be a programming language, it's just some way of communicating, and I think we need to rethink that format as well. It needn't be Python or JavaScript or C++. We should think about, okay, what are the other formats in which we can program as well. So I think a related point is, while AI is taking away a lot of things that people do, it is also like adding a lot of topics that we need to think about. So that this is, I think, the opportunity for academia in particular, is that, okay, you have all these new research areas that are very important and we need to focus on them. Yeah, thank you for the questions. Any other questions? Yeah.
Yeah, no, and this is about the two thoughts you leave with us. One is, what are the courses from academia point of view, like what we need to have in 10 years, and the second question is like, I mean, more than a question, I'd like to just leave with you and others, like what IIT has been doing on the first challenge, right? Because I have been fortunate to sit in product development meetings in my software house as well as here, because I work for the group, so I can see in terms of product, like what we need in the software. And then I come and sit with the faculty staff to think about the products that we need in IIT, what are the degree programs that we need, right? And we have two faculties, engineering and business. Historically, IIT is known for our computing.
It's in the name also.
Absolutely, right? Like, and some people even ask, like, do you have business? That level. But 2 years ago, I started, because when I sit with the business faculty, deans of TEMA here, right? I started telling these guys, look here, you can be bigger than computing one. You now start developing computing courses. Right? This is what I push to business faculty. The computing guys are here now, they're probably a bit disappointed. But, you know, I've been encouraging my business faculty staff to start developing computing courses. That is not to replace the software engineering degree, but to think the computing courses that you need from a business perspective. When they put together, they actually do what you said at the two corners. Right? They look at not the engineering part of it, but what constitute at the two ends to make it. So we have started something. On
Great.
Those lines,
That's really good to hear. And you would so IIT is informatics, right? So another MIT back in the US is, again, Institute of Technology, but they have a business school, they have economics school, they have actually liberal arts, all of their music, they have all of that. So you should definitely expand. I think the survival is about expanding.
Thanks for that insight.
Any questions from people at the back? Oh, no, please.
Okay, Duan. What's your advice for today's undergraduates or their parents about the decisions they have to make for the future?
I don't like to give advice, but I'll say what I do for myself. Like they say, what is it? Do as I do as I do, not as I say. Right? So I think one of the things is, again, we should focus on areas which we have reasonable confidence that machines can't do. And so I mentioned two things relevant to the software industry, but I think we should also focus on things like creativity, So I think one deficiency in our education system is like we specialize very early, and so if you say let's say computer science and let's say Sinhalese literature, those two branch out very early. Like if you want to do computer science versus Sinhalese literature, the branch happens at O-levels, in the O-levels, because you, for A-levels you have already branched. So I think one thing that will help is like if students who study computer science have the opportunity to study things like the arts, economics, laws, things like that, diversify them, because that will like stimulate their creativity. Because it's easier to solve, like for example, the startup that I mentioned is in finance, economics, that space, and if you have some background in that, you combine that with technology, you have a lot more space. So a piece of advice that I got from like some very useful advice that I keep following is like, it's very difficult to be the best in the world in one thing. It's much easier to be the best in the world in two things. Like a combination of two things. So I think that's related to my earlier point that, okay, go wide as opposed to kind of specializing too early, because I mean, you might unluckily specialize in the thing that AI is very good at. Yeah, I can't really give advice, but these are the kinds of advice I like to follow myself. Yeah. I don't know. Yeah.
Recently, we have been doing some projects generating code.
Yeah.
And first we start with the vibe.
Yeah.
And then what we realized was to design it, we used Codex and ChatGPT.
Yeah.
So the first we started with the vibe coding with the Codex and also the Copilot.
Yeah.
Later on, what we realized, designing, as I said, it's a human thing, but ChatGPT started designing and giving the prompt to the Codex.
Right.
So now it's actually what I realize is learning more and more, and is better than what we are doing right now.
Yes.
So I think the future is, so the first thing is, I think, what I have realized, even writing, for me, I write a lot.
Yes.
And I realize now he is learning the style that I write. So this morning also I realized that some of the things that I write, and there is no change at all. There is no, I mean, it's exact. So the future is, I think, for what I realized was, now I come from natural sciences. I think the coding is going to disappear, most likely, but we have to have coders who to understand some of the errors. So that also we have to keep in mind. But I think for people, what we should do is we have to give them more natural sciences and liberal art background. That way, I think that innovation plus the thinking, we can keep going. Otherwise, I think I feel really inferior to the coding and even designing, architecture side.
I kind of agree with kind of almost everything that you said. Just one caveat that I would add is, back to my original point, you still need someone who can take responsibility for the code.
That I accept. That's the only thing I think you take someone to code. But when I checked my code, I mean, we are doing some project on the fingerprint. We are developing another system, and he did it like in 2 weeks. All the things that I did for 5 years.
And same thing applies for like other types of writing. And so I write a lot of like kind of prose articles. Again, if I write something wrong, I can't blame it on. I have to take responsibility for that as well.
That's the only thing I think.
Thank you. People from the back, questions? I can't hear. I think it's working now.
Okay, can you hear me? Yeah, so we also started into doing some developments using AI. So as you said, we started on, we got a prototype. So we give the freedom to the AI and it gives us a result. But what if we don't want to accept that? Because so right now we are from Senate. So it's a 20-year-old software system. So we have a pattern that we have been writing, and so at first it did follow the same patterns that we use, and it was very hard to understand, and we had to wipe everything and start again. And we initially started this to like cut off efforts, and we need more efficiency, but it was dragging more time. And then we went into doing spec-driven development. So we started like as taking like rounding up all the requirements that we want. So we put them into a document. Like we started writing specs, adding skills like instructions, and defining agents. Like these are the agents. So we followed clean architecture. So we added another agent to like see. This is the file pattern we want, and. This is for a complex system, so we were developing a performance management system, so to manage all the KPIs of employees within a year. So we actually almost everything we documented, and we feed the document into the AI, and it still gives us some hallucination. So I wanted to know. So when we're taking the responsibility, like giving all the requirements, like how much deeper we have to go into, because we are right now documenting almost everything, but sometimes it makes a lot of difficulties and different codes and different logics that it starts hallucinating.
So it's a very, very important question. It's also the solution is very broad. So I'll just say at a very high level some principles that you can use. So the quality of your code, how you validate it depends on your risk appetite, right? Like, so I mentioned the example of a plane, like you have a different standard of risk if you're flying a plane as to say like say like payroll software or something like that. So the approach that I take is for everything that I feel is important, I have tests. So like in parallel to your spec-driven development, you have like very kind of rigid test-driven development. Anything that I know can go wrong must be tested. So I have a lot of tests. And I also follow the principle that now you can use AI to generate the tests as well. You need to have some proportion of the tests that are human generated. So you know that like the most important things are tested. So that's kind of one thing, and this applies to functional and non-functional tests. So both things like correctness and performance. So that's kind of very important. And your question on how you take responsibility, I think it'll be proportional to the tests. So for everything that you need to take responsibility, you have to have tests, and then you run those tests, and then you know it works. So I think that is the approach that I would take.
Right. Okay. Thank you.
Two more questions.
I have a question. So.
Sorry, where is the?
Over here.
Oh, okay.
So it's about giving carrots and guiding people towards a direction.
Yeah.
So our marking, our way of teaching or guiding things are not giving responsibility for the student.
Yeah.
Yeah. We are more into fine-grained control than holistic development.
Right.
So how does that actually, as a generation also, like when I was like 20 years ago, I passed out. So how we were given chance to fail or chance to take responsibility, I think this generation is passing out is not getting.
Yeah.
So how are we going to go about it?
So it's a very good question. I don't have a good answer to that, but I'll tell you kind of a quick story. So a friend of mine who is he was a student when we were friends. So he's a math student. Now he's a maths professor, and I mean, just like programming, kind of mathematics is also like a programming language, right? Like but the difference is you got a lot of programming languages. Algebra is one programming language, geometry is another programming, calculus is another programming language. So I actually asked him, like, I was just curious, like, so you know, like students use AI to cheat at exams. I asked him, okay, don't mathematics students also kind of cheat at exams? And he was actually saying that, so he's at the University of Texas in Austin. He was actually saying that math students, for some reason, like take more pride in their field and they don't cheat. While at the University of Texas, computer science and all the other students use AI to cheat. Math students don't cheat because they are like very small and they kind of take pride in their subject. And so I kind of realized there is like the difference there is, it looks like the math students are kind of more intrinsic. They are to what they get, while a lot of the other students want to pass the exam. So they are to like show other people that they're good, while the math students are there to show themselves that they're good. So I think this shift needs to take place, because I know it's going to be very hard to design exams which are like cheat proof. Now actually there are like competitions for seeing like how well you can cheat, because like that's how difficult the problem has become. So I think we need this kind of shift where students come in to learn as opposed to kind of getting the degree. So I don't know how we are going to achieve that change, but I think that's the kind of the end game. Yep.
We're open to one final question.
Hello.
Yeah.
So during the speech, I was listening to the interview part. So there in the reverse interview section, you said that the skill that you're looking for is like problem solving and logic, understanding logic and stuff. But then the issue with that is that it's a skill that you develop on the job, right? So how are we as first year students supposed to develop that skill for the interview, which is something you get on the job?
So just to be clear, the reverse coding question is like you give the candidate some code and they kind of they have to find the bugs in it. So what I said that people mostly tend to learn on the job is, one is translating, understanding the problem. So that's not problem solving, it's understanding the problem. Like that we need to solve this problem and not some other problem. So that's one. The other is given a solution, understanding that it is solving the problem that we want. So I think the reason that tends to be this tends to happen on the job is like jobs tend to be kind of more practical, while kind of school tends to be more kind of theoretical. There's no reason why we can't do more of that in school. So we just need to kind of do a little more of those practical problems as well. Also, it doesn't necessarily mean that you need to do this at university. Maybe there is some intermediate place where like an internship or something where these skills are cloned. I'm not actually saying where the problem needs to be solved. It needs to be solved somewhere. Maybe it's university, maybe it's kind of in industry, maybe it's somewhere in between. Yeah.
Thank you.
Yeah.
That's it for the Q&A session. Thank you, Mr. Nawaz.
Yeah, thank you.
Next up, we are opening our presentation block. Over the course of this session, sharpest minds in the industry will share their perspectives on where this technology is heading, giving us completely different angles on the future of AI engineering. To start things with our first presentation, titled AI Copilot for ERP, Agentic Code Generation Across Middleware and UI, presented by Mr. Samudra Kanake-Arachi, Director of AI and Research at 99X. Mr. Samudra?
Plug it in here, right? Yes. Plug it.
sometimes from manual coding to vibe coding. Now we are talking about agentic engineering, right? So to give the perspective, so this is from one of the project that we adapt agentic coding inside the company. So it's a ERP product. So it's a sales to manufacturing complete end-to-end engineering cycle, managing using platforms. And we use agents to develop these platforms. Originally, we are coming from human-led computer engineering. That means our knowledge and capabilities are with humans. Like we are talking about people with 30, 40 years of industrial experience who has technical knowledge, business knowledge, and also the other knowledges are scattered. Like if you take the real knowledge, it could be your documents, it could be your tools, and it could be your people, right? And the whole human-led platform, it was operating on Scrum, a manual process designed to work with human. And we have very complex infrastructure like cloud services. So that is the whole holistic context, right? So if you look at this environment, onboarding a developer, new developer into this platform, usually it takes at least a year to train him and make it productive, make him productive. So if bringing a human developer is that hard, if it takes 1 year, so how difficult it could be to bring a agent, right? So whatever we said and done, if you have to bring agent instead of a developer, so that will be a very hard process, right? So the way you start, like if you take 2 years back, the way we try to bring agents is through vibe coding. That means you code just assuming that you don't have code, right? So you use natural language and you describe something. So I want to create an old application. Then suddenly you have the old application, right? So code get generated automatic. But if you really look at what's happening, every year, every 7 months, agent's ability to generate code length, it doubles every 7 months, right? So the code generation is on exponential rate, but the ability to validate what you write is diminishing, because when you generate thousands of lines of code or millions of line codes, there's no easy way to you that can validate, right? That's the real issue. That is why vibe coding doesn't work. It's engineering for everyone, so everyone can code, but can you validate the code you write, right? That's where you bring this spec engineering, context engineering, because then you spend a lot of time on designing your code and generate code systematically, then you have a better engineering process to control the code, right? So that is why you brought up context engineering and spec engineering. But that's also not so efficient, right? So we bring architects, we bring developers into your code, but these engineers, agents, they don't understand your context. They don't understand your product or your platform, right? So if you really look at what's happening is, originally you were expecting like bringing an agency will have maybe 10x improvement in the productivity. But really what happens is, what you get is maybe 20 or 30% improvement, because these agents, they don't understand the platform. The code they generate is not so accurate. You spend a lot of time in designing specifications, so you don't get the expected output. And also this traditional Scrum process, it is designed for human, not for agent, right? So what we should do? So that's the next question. So if you look at what is the real problem here is, so you don't have a shared understanding between human and agents, right? So if you take human architect and agent architect, so if you can't do pair architecting with a human and agent, pointless, right? So then you have to bring shared architecture knowledge.
if you can't do pair programming with the agent engineer, so you have to bring pair coding knowledge, pair designing knowledge, pair UX knowledge, right? So you have to build a shared understanding layer if you are to bring agents into these systems, right? So the way you do it now, so I think this is a very rarely heard term, we call it harness engineering, right? So it's much bigger than the context of agentic engineering. So where you build tools, skills, just like how you build humans, right? So if you are to build a human from a small kid to a matured person, so what you do is you teach teaching skills. You add more skills, right? So you are not upgrading your intellectual property, rather you build skills into people, right? Same way, into the platform, you add skills, you add agents, you add workflows, so you bring the holistic system into a different context rather than trying to fix micro workflows. So harness engineering is the process of mixing context, then mixing tools, workflows, agents to get to build a harness. Like I can very easily explain it using a car. Imagine the brain of your car is your engine, right? But can you drive from Colombo to Kandy by using an engine? So you build a harness around your engine so that it do a purpose. Similarly, with a LLM, you cannot build a system to work, right? So you have to build a harness around it so that you can get something done from your LLM. So that is what we call harness engineering, right? So I'm rushing through the whole context because I wanted to do a demo. So one of the first step so I can't see. I want to move this into the other part. Okay, yeah. So one of the first thing we did to build a shared knowledge, we called it building knowledge graphs. So we call them obsidians. So what we do is whatever is available in your documents, whatever the knowledge in your people, so we construct wiki type of graph structures to record the knowledge. So you have a graph-based ontology which describes your product, your architecture. So this is done at different levels, like you do it in your product level, API level, architecture level, design level, code level. All the artifacts, we convert them into knowledge graphs. When you have your classic knowledge in knowledge graphs format, so you can query these ontologies using your agents, right? Then when you ask a question about your product or your architecture or your APIs, these ontologies will start giving answers. It's like you have the concept of subject verb object. So that is how describe phenomena, right? So if you build such sentences in millions terms, so you have a massive descriptions about your product and your architecture, right? So if you invert this subject verb object, then you get the question form, right? So then you can query these graphs and enumerate very valuable informations. Now you have human understanding and agent understanding on top of these graph databases, right? So when you have this, now what you can do is, I hope you will see this. Give me a second. Yeah, but you will get the understanding. So sorry for it's not coming up because of the slow network. So now with agents, if you ask something about the architecture, so it will give the visual representation of your architecture. And if you ask anything about, let's say I want to develop a sales order application, then the questions are, I want the user experience design. So can you plan your screen? So these agents will show up your screen and do the right designing, and it will like come up with the right user experience, right workflow, and it also will query the API graph and identify which field to enumerate and what are the field mappings. So it will do the entire architecture from the API point of view, technology point of view, so it can do the complete end-to-end design cycle that usually a human developer will do, right? So you can see that when you have this kind of shared understanding layer, then only you can do pair designing, pair programming, pair coding on top of your entire product platform. So that is the first layer of abstraction that we usually do, right? So when you have this level of comprehension, pair activities, when you can do it, now you can bring a completely different process other than Scrum. We call it agentic development life cycle, where agent will understand how to do planning, how to break down into tasks, so that you can bring agents into a completely different AIDLC, we call it AIDLC, so where agents will do the designing and whole process, right? So until you do that, you cannot bring a complete different process because you don't have the shared understanding. This is what we have been doing.
Thank you, Samit.
I think it's running out of time, so.
I have a question about so creating this knowledge graph. How does that happen? Is it like this guy?
Also itself, it's an agentic process. So where we scan all the existing documents and do interviews with people. Like, so if I'm an experienced architect, then I do an interview with the agent and I describe how I do architecture and how I understand my product. So it's kind of a lengthy interview. So it will build the graph while I am chatting with these agents. But if documents are static, so we scan through all the document structures and we recreate these graphs in the text. And even code itself, we scan through the code and then we identify the hotspots, design patterns, and so that it will build a code graph and then enumerate through the APIs and create API graph. That is how we do it.
This Karpathy's LLM wiki, is it
it's the
similar?
same Obsidian, that is the LLM wiki. So
okay. Questions?
So you talked about that when the agentic AI is becoming better at coding, that the human ability to validate the code going to get lower. So then imagine that your company get an intern or someone like that who is very new. So then what are the steps that you could do in order to make that this new student into the level that it could be a good, take that person to a better understanding level. What is the steps that you could take? Like for an example, I am hiring an intern and then I am giving the particular project, and then it is really difficult to ask the person to really do even though we do have vibe coding, sometimes it is not going to work because the student does not have the understanding that really need. Because when we were doing the programming, we had the idea, but now the student does not have it. So how are you going to do the development of these personal skills?
Yeah, so it can be done in two different levels, the bottom-up approach and the top-down approach. So usually what we do is we keep students more on design activities so that they will understand using Markdown, using different visual elements, how to do a better design, right? So when you do a better design, so nowadays these agents and the LLMs are good enough to generate a very comprehensive, correct code. Like it's the same issue that we had with assembly some years back. So if you are coming from assembly background, so I might very good at assembly, but I am very not comfortable with modern languages. So same concept, but if you can do designing better, future probably you will not care about much about the if and thens and while loops inside the code. So it's just an artifact and you don't care about whether it's Java or TypeScript or whatever the language. But if you are a good designer and if you are a good system thinker and if you can give good instructions to your agent, that's what matters, right? So you will be surrounded by a large number of agents. If you can control them, that is the must-have skill in the future architects. So we will not hire people to code. We will hire architects who can design systems and drive this agentic process. So that is one level above what you're looking at as a coder.
Thank you for that.
Yes, I think that is the change that we have to start making, like instead of teaching languages, teaching code segments, maybe code is a part of the curriculum, but most time spent on designing skills and working with these agents. Those are the must-have skills in the future students.
people designing, but when they come into the course, they don't even know what is software. So that's the challenge. So how do you? So there is a, there's a gap between where, I think that is what she's also talking about. There is a gap between where the student is.
Yes.
And where you start off. So that huge gap, how do we cover up? That's the big question.
Yeah. I think it's a combination of pet projects and changing the curriculum and start some pre-degree programs to facilitate this, bridging this gap, because I think it's more like 1, 2, 3 years of exercise to cover up the existing gaps. Probably the younger generation, they will follow because already they are seeing this change. But the issue is for the current generation. So they are in a different state. So I think as industry, I think we also have to contribute to that. And as academia, we have to contribute. That's a journey that we have to take all together.
Yeah.
Mr. Kanake, a lot to think about there. Following up, our next presentation, titled EWIS Aegis, an intelligent platform for automation legacy software modernization, presented by Mr. Isuru Disanayake, Chief Technological Officer at EWIS Group. Mr. Isuru.
Good morning. Unfortunately, Isuru has a family bereavement today and he's unable to make it, so we have a team up to do the session for you. I have Bhuendra here, who is the tech lead, who will do the presentation per se. While he does set up, I just want to pose this question to you as the audience. Would you rather develop an application from scratch, or would you prefer to take the existing application and modernize? What do you feel? Anybody? Some thoughts? So let me just add to it. Earlier on in my career, I preferred to do things from scratch, because you don't want to fiddle around with what someone else has done. But as time has gone by, we've realized that applications have a lot of know-how that is not actually documented. There are a lot of things that have gone in which is not visible. So is there a way to capture this? So this is the idea behind what Aegis brings to the table as a platform. We are capturing the know-how that has gone into the system, and we are keeping it and moving it forward even as we modernize. So I'm giving it over to Bhuendra here, who will quickly run through. We are aware of time, so we are going to try and do a demonstration as well, but without actually generating it on site. Over to you.
Hello, everyone. Hello, everyone. This is iCIIT. I'll just start by explaining what our solution is, and then maybe we'll see if we can do a demo. Yeah. So our platform is essentially AI-powered legacy software modernization platform. Essentially, what it does is it will analyze a legacy system to get the context of what the solution and the business logic and all the facilities in a solution is, and then recreate it to fit the new, more latest stack of technologies to help engineers as well as anyone who wants to go into like newer integrations or newer cloud environments, so doing different integrations to systems. It will help them to move forward. So our solution allows us to, first of all, analyze the legacy code, as well as then go toward the modernization to almost any technology that is currently known. Even technologies that is very, let's say, not used as much, we can actually do it if the requirement is there. How we do it is we essentially take, I think I went through this, I'll just glance through this very fast. The digital twin environment, which is one of, so I think even in the previous presentation, we talked about how LLM AI itself isn't going to help. This software and the infrastructure around it is what actually is going to help us do something, right? Or create a solution. So in this case, our digital twin environment is one of the key components in our solution, which allows it to create mock environments of other integrations that's happening within this legacy solution. For example, let's say in a banking sector, there's a core banking system, and there's a smaller system that they have created, which is in a very legacy language. If we were to do the modernization, we wouldn't have information about the other integrations this software has. This creates a gap where even if we try to provide it to an AI and ask, here, I want to do this modernization, if the AI doesn't have that information, it won't be able to really give a really good result. So what our digital twin there does is it creates a mock environments of these integrations using the legacy system to essentially, allow the AI to, fight back and forth with this, to keep it under a scope and not essentially go and do something that is not intended. That's just one part of the digital environment. There are others, like a couple of workflows to pipelines and a few other integrations. So this is business stuff. Yeah, essentially I will go directly to the demo. I think I have like 5 minutes. So if we had time, I would be going and doing a modernization of this jQuery application, but I'll just go through our application to show you guys like how this works. So essentially, we can start by creating a project. We will give it a quick name. And we can provide the source code through Git URLs or through uploading the zip file if you have one. And here it just gives some information based on like how much tokens it's going to use to do the initial analysis, and few more information based on that, based on like essentially the legacy application we're uploading. And this part comes here to essentially how you would describe as context engineering. This is where we will actually give the initial context of what the legacy modernization needs to happen. So here we have some templates we can set up, but I'll just glance through them very quickly. So I'm going to provide like React and target version as 18 to do the modernization. The previous legacy code's technology is not required here, mainly because it will be captured automatically. And we have some points to add some special instructions. So you can see it's pretty detailed. And some additional coding standards to migration nodes that might be there. So if we were to have any support documents for this application, like SRS documents or anything like that, we can actually upload it here as well to give more context to what we want to build here. So going forward, we have upgrading rules. This is something I think most of everyone uses AI now to do coding or essentially vibe coding or something, right? This is one of the main points I think that is required to learn when we are prompting like an AI, essentially mainly because positive and negative prompting is what's going to keep the AI in a scope without having it to go to more hallucinations. So this is essentially a place where we have allowed it to do it. We will provide a positive information to derive what it needs to do, and a negative prompt to say these are the things that you're not supposed to be doing. I'm going to glance through that. Once we come to this section, we'll actually get another estimation of the tokens of how much it will actually cost us to do this modernization, and a few models that we can select through, as well as we can do some configurations. I'll just go through these very quickly. All right. So essentially, now our system is going to start doing an analyzing. If anybody has used Claude or I think even Copilot now they have this, there's a plan feature. Essentially, this is something similar to that, but we have a few more workflows running internally and a few more agents running internally to get a bit more context out of the source code than a traditional context extractor. So here, once the analysis is done, it will actually give us more summary, the architecture, the standards, the routing, how much features, what are the features that was there, as well as the data models. All this information is grasped. And it will then go ahead and start creating the blueprint, which essentially is the plan in terms of if I were to compare it to Claude's planning feature. We can give that a couple of minutes. Yeah. All right. So here we can see this is the blueprint. It figures out what the target it is and gives you a description on what it's going to plan on doing, as well as like the folder structure and all that information for this application. So I can proceed and start this, but this is going to take about 5 to 10 minutes to actually do. We don't have that much time, but I can show one other simple thing, which is once this solution actually goes through, another workflow actually triggers and creates few reports, essentially similar to this, which shows like the modernization full plan. And it's extremely detailed, and it provides like every feature, how it's going to be modernized, every how what's the plan is, what's going to happen, what happened where, and everything is in like very in detailed here, as well as a vulnerability report of the previous legacy application, or even the new application if required, is also generated, which creates a detailed vulnerability report just for the code, not for anything network related or anything like that. Just for the source code, it is created as well. That is pretty much EVZGs, and I would like to take any questions if you guys have. Oh, right, yes, of course, forgot. So if we were to do this live, I would have had to put this system through the our system, but this is a legacy application done in jQuery, and if I remember, yeah, and this is what the normal modernization output would look like if we went through this. So it's the previous legacy is like this. It's a BF-ETF calculator, and pretty much. This does the same thing, but with much more new features as well as much more prettier UI, I would guess. Yeah. I would like to take questions.
Maybe a very quick question.
Yeah.
The digital twin, is it created manually or?
No, it's again going through a layer with our NLM to create like a couple of workflows to create that model as well, mock environment. We do essentially, our engineers as well as myself, as well as our architects go and check on those from time to time, just to make sure if everything's correct. But apart from that, we don't really need to like hands-on work on it as much.
Can you tell me, can you speak a little bit about how this product scales as the size of the legacy system increases,
right.
Especially with respect to things like hallucinations and kind of things, kind of big logical errors, basically, yeah.
Yeah, essentially. So one of the key things for smaller stuff like this, it actually, we can do it in 5 minutes or something through like a demo like this, right? But when it goes to larger scale applications, we don't, the UI you just saw, we don't really use that directly.
Sorry, could you give me a sense of when you say small and larger, like in terms of lines of code, what's the size?
It's basically lines of code, complexity and functionality to a combination. How would we scale it, right? But I would say maybe like 200 lines of code with like a couple of functionalities would be a small one. But when you're talking about large scale applications, like 100,000s of codes and maybe hundreds and thousands of like functionalities will be there. That's essentially what I'm looking at. Yeah, and. So if we were to do something as big as that, we would be directly actually interfering with our main and backend environment rather than using a system to go through it, since this is a private, like in-house built application. So when we're working with it, we do have to, we will have like an iteration, which would, actually, you asked me about the scale, right? So, sorry, scaling, right? So when it comes to that, I think, we have a couple of workflows, few practices that we have set it up, which allows us to either break down particular contexts to what we need. Essentially, how I could explain this is, so let's say we have a 1 million context window that we can work with, right? And let's say, for example, 500K of that context we are going to use for the primary information, which is the information that does not change, the business logic, the functionalities and everything. The rest of it, we wiggle around. We make sure that it can move around and change according to the task it's currently doing, right? So that's essentially allows us to, without having to, let's say when the scale increases, the lines of code, it goes to 100,000, we don't have to give that 100,000 of lines as a context, right? We reduce it to like help us on the particular task it's working on at the current moment, so that the context window gets lower, and because of this we can scale up to like a higher software solution that we're doing to be able to actually go through this process. But the downside is it does take a lot of time, because essentially to create like a simple app, 5 minutes, sure, but when it comes to a bigger app, it would take like a couple of weeks to a month even for the first integration itself.
Thank you.
Yeah.
You also said you run this locally, right?
Yes, we have a couple of H200s running this environment.
So what's the biggest model you can use on that?
125K Quen 3.5, if I remember. That's the main model that we like, the biggest model I think we have tested out yet. I am testing out a few other ones, but that's one of the models that we're trying to use.
Questions? Just put your hand up, then the mic will magically come to you.
Good. Yeah. Thank you, everyone.
Thank you, Mr. Buendra and Mr. Nirmal. Really appreciate that perspective. All right, 2 presentations in, and I think we've all learned a quick break. So refreshments are ready for you just outside the hall in the room 7LD. So please go grab a drink, get something to eat, and stretch your legs. And I know that the best conversations happen around the snack table anyways. And we'll be starting up exactly within 30 minutes. Enjoy the break. Welcome back, everyone. I hope you managed to grab some refreshments and stretch your legs. So diving back to our presentations, we have our next set of industry specialists line up, ready to give us their unique angles on where this technology is heading. So let's get right back into it. So to continue, our next presentation titled Custom MPC for AI Native Software Development and Agentic Engineering, presented by Mr. Anusha Samarakkodi, Associate Tech Lead at Dialog Asiata PLC, and Mr. Asiri Samaraveera, Technical Team Lead at Dialog Asiata PLC.
Good morning, everyone. So I am Anusha from Dialog Asiata PLC in our IT division. So today I want to share something very practical, not a concept, not a pilot, but a real AI agent we build and deploy it inside our engineering workflows by using our custom MCP. So this is our agenda. The first two slides actually we are fully focusing on the agentic engineering and how we, and I will explain you how we adapted and how we build the agentic agents by using our agentic engineering platforms. So so in the first slide, we have focus 4 area to cover: our BA agent and the code review agent. So and L4 analysis using the MCP stack and the BMAT framework and the live demo we will show you. So in this slide, let me start with the pain point we felt every single day. So our business analysis were manually written the BRD and FRS document from scratch and every single requirement. So every project problem was not just the time it took, and it was inconsistency. So different BAs and the different style required that the look at the complete, but had the some missing acceptance criteria, ambiguous the statement, and the conflicting the inputs. And the worst part is the problems only surface during the development or during the testing. When the fixing them, it is the expensive. So we asked what if an AI agent could catch this problem before a single line of the code is written. So actually we build the BA agent so that the multi-agent collaborations we are using for the multi-agent collaboration we are using the Amazon Bedrock. So we have a supervisor agent, review agent, BA agent, and the FRS agent. So both agents are actually we built and grounded into the dialog on Confluence, our past BRD, and the FRS template, and our telco domain knowledge. So basically we created the graph vector database, graph, and the semantic and the structured vector database we are using for that. So when the requirement comes into the agent analysis, as you can see here, so generated the structured BRD and FRS, and the flags and ambiguities and missing the critical immediately. So the outcome is the requirement quality improvement, and the network during the development reduced significantly. So I am moving to the next agent. Next agent is our code review agent. So basically our developers merge their merge their branches into the release branches. Then after automatically triggers our code review agent. We have a webhook, so that webhook automatically get the code diff. So when you, let's assume you have a feature branch, so then after that feature branch need to be moved into the production deployment and the production deployment. It means that release branches. So then after we need to our webhook automatically triggers, and the webhook automatically trigger from our CI/CD platform. Then after get the code diff. Then after that code diff pass into our code review agent. So actually, in this code review agent, we given the we added the 6 pillars. As you can see here in the right side, we given our we created the own knowledge base by using our own documentation. We added here into our knowledge bases to AUSNAP, NIST guideline, ASIATA DevSoc guideline, Telco domain guideline, clean code architecture, dialog coding standards, and the Confluence repo and ODS we are using for our knowledge bases. So so this is the in this actually so in this code review agent, so mainly we are daily receiving the 15 code mergers daily we are receiving. So that code diff automatically triggers our code review and the code review, and automatically that particular response and particular feedback, code review feedback put into our GitLab. So the outcome is the systematic and consistent and the quality of the enforcement, and not the depend on the who received your PR that day. So I am moving to the next slide. In this slide, actually, we are in dialogue. How do we resolve the L4 tickets? So I will explain you. So so now let me take you into the production. So where things go into the wrong at 2 or 3 p.m. So our L4 support engineering handles the complex production incidents. So when the incident is hit, what they have to do is they have manually open the logs and checks the logs and manually query to the Oracle database and manually checks the Kubernetes ports and EKS in ports and health on the EKS, and manually review the Jira ticket on the Atlassian, and manually cross the reference of our source code into our GitLab. The files is these are the 5 systems we need to check. The 5 system, the 5 browsers tab, hours to context the switching the production to production is down. So this is the reality of the enterprise incident management. And now here is something important is our original plan is going to resolve this our L1, L2 support team to first. But L4 team engineering need to it more urgently because they are once doing the depth cross system and depth cross system investigation. So that's why we started there. So in this solution we are using for the MCP stack, model content protocols. So that's why we use the model content protocols. We are not using the open source code. We are not taken, and we own build. We are own build and we are customize our MCPs, because the main problem is, so we you might ask why not connected AI directly to those systems, because in the enterprise like the dialog the security is the non-negotiable. So the MCP gateway handles the authentication via, so we are via from our Azure AD platform, and then after we added our key clock authentications, and as you can see here, we are adding here the rate limit, logins, and the sanitizations. Both are we are added here. So contextually reach of our entire enterprise tool chain with the full security guardrails. The outcome is outcome is, so we are actually, we can't avoid our security. In the first priority is security. So I am moving to live demo how we can L4 tickets are coming and how do we resolve that particular issue into the issue.
CBFO
So this is our Nilu. So this is this agent capabilities to Sinhala. So all these this agent have multiple capabilities in capabilities to call in the tool calling. So and also this agent autonomously call our MCPs and connect into the backend services, and we backend services and get the response related into the L4 ticket. So first of all, we need to put into here only customer issue ID only.
69යි 831 ඇනලයිස් කරලා විස්තර කියන්න.
So then after Nilu is agent will analyzing the all the MCPs and our database, get the database, and so then after quickly get the response. Actually, this is when we are doing into the manually, so it will take the lot of time for the lot of time and effort need to be put into the developer. So then after we will reduce our developer effort here. Thank you. Thank you so much. So I will hand over to next session, wipe coding part into the iCIIT. Thank you.
Thank you, Anusha. Good morning, everyone. Before going to discuss about wipe coding into agentic engineering, I'm explain about what are the waves and actually that we have faced, what are the problems in that waves and why we move into the agentic codes, agentic engineering. So first of all, in first wave, actually we have used general purpose LM like ChatGPT, DeepSeek, likewise. Then actually we using that kind of LLMs, we actually face, we have not proper context in that environment. We have to put something into DeepSeek, ChatGPT, and time to time we have to input a larger prompt there. Also we have to have proper prompt knowledge as well. Then we move into wave 2, coding LLMs like auto-completed plugins, actually use Copilot, Cursor, and we use IntelliJ AI plugins. Also, we can chat and it will auto-complete our code base as well. Then currently we move into agentic engineering. Actually, we have Kiro, then Cloud Code, and also Amazon Q provide better local agent frameworks. Then we can customize our agent. That is the way. Also, I'm going to discuss about what is the current dialog team are using, what are the technology and tool stack. In here, we using Kiro plus BMAD local agent framework for build our software system. Now I'm going to tell why we use BMAD. Because when using Amazon Q, we can also create customized agent, but using BMAD, they provide ready-made templates agents. Then we can customize also. They have also predefined workflows. Then we can easily manage BMAD with Kiro IDE. What is Kiro provide? They provide MCP integrations, then parallel agent concept. That is the main purpose why we using this kind of technology stack. Now I'm going to move small demo, then you can understand what will happen here. In here, this is a small business requirement document. This document I have created using Amazon Q plus Kiro using BMAD BRD agent. This regarding simple shopping cart application. This is the BRD document. Then you can see here, this is the this is the BMAD skills. You can see dev engineer, dev, QA, architect. It's provide more powerful skill set here. We can okay. This is the BRD I have created using BMAD and Kiro. I'm forward a little bit here. Then this is the ready-made BMAD agent skills. You can see architect agent, UI, PM, dev, PRD create agent. Likewise, there was predefined custom agents. Also, we can customize using customized flows using these skills. That is the way currently dialog we have using. You can see this is the steering documents we have provided to Kiro. Actually, this has a standards dialog, coding standards, and documentation standard. Likewise, we can provide set of instruction. In here, this you can see MCP server we have integrated, sourcebot, PostgreSQL, Playwright. Likewise, we can integrate. Then I'm asked agent to create architecture. You can see here. I'm called /BMAT agent architect and create documents. You can see created architecture document, layered architecture, sequence diagrams, also ER diagram as well in below. This is a ER diagram. Then I'm asked /BMAT agent dev to build this shopping cart application. Actually, in the past way, we have to put some documents, we have to update some documents, we have to know proper instructions at how to provide the instruction. In here, we no need to worry about that. They provide a set of well-built instruction set, and proper commands. This is a design automatically generated by BMAT. Also, we have to review it. Actually, this is autonomous process, but human involvement is mandatory. Otherwise, we have responsibility. That is the way we do it. This is a task list they have generated. After complete those tasks, mark the task has completed. Now, here you can see task mark completed. Then I'm going to run application. I'm asked run backend and front end. This is the generated application. This is a simple shopping cart. It takes actually 2 hours using this BMAT and Kiro. If it's a complex solution, it will take more than 5 to 8 hours. It will automatically create unit test and reports. This is a document generation. It will create all the documents. We have to review that one. So project overview documents. This is API documents. I'm going to show how it's work in unit test, and this is a test generation. Actually, we have used Playwright MCP for automate every UI backends using Playwright. It will use Playwright MCP for development of their autonomous automation systems. Now Playwright generated the automation. Now it will run the automation, and I can show what is the output of that. Now I'm asked run the E2N, start the test automation, and it will generate this output, unit test pass, and then run performance test as well for backend service. Run performance test. You can see I'm just type run performance test. It will automatically know what will call and generate the output. Actually, that's it.
So, do you have any questions?
Do you have any questions?
So actually, so because that, so when we are taking, so the concern is the security. So when we are using the...
You can answer to the mic is better.
So, can you hear me now? So, so why we actually using the existing? Why don't we use the existing one? Mainly reason the security. In the dialog is thoroughly checking for the security, because the all data into the customer related. All the when we are creating the SIM change related, or all the documents related to the customer related documentation. So that's part we are. So that's why we created the all. That's why we created the own vector database to connect our LLMs. So connect the LLMs. So mainly we use for the AWS cloud resources. Resources using to create the LLMs and created the knowledge bases and the vector database. Mainly the security. So we can use the open source search one, but open source one, but so we don't know that data is going to that data where is going. and trained, because the customer data, because customer data is sensitive, and if they are trained that those data, so that will be affected into our day-to-day operations and our main business.
Yeah, your data,
Yeah.
like, so you train the LLM locally, on local servers, or you on the...
No, we use for the AWS services.
But how do you now even you have the personal data now?
Yeah.
Basically, I mean, the PDPA does not allow you to, I mean, you can't send the data to the cloud also, right?
Yeah, but we have a direct connect with the AWS in the Singapore to the Sri Lanka, and we have direct NDA signed with the AWS team.
But does that allow you with the PDPA?
Yeah.
I don't know whether legally it is allowed to the cloud. No, I mean the Personal Data Protection Act. Now, when you upload the data into the cloud, especially the financial data, you can't do the central bank controls that. But the PDPA specifically talks about the personal data without the consent from the person, the relevant person. You can't actually put the data to the cloud. I mean, in the sense also the data retention, there are certain rules right now governed. So one of the things is that when you put to the cloud, when you upload to the cloud, you need to get a permission from the relevant people.
Yeah, we are not put into the customer data.
That's what I am asking. Even other data, like there are certain, like related to your, let's say your staff data.
Yeah.
That also there are certain restrictions.
Yes. So we are masking that.
Yeah. So you need to anonymize that.
Yeah.
The mask it and anonymize it. So that I think you need to go through. I think Personal Data Protection Act is very specific about it.
Yeah.
So that's why. But you have your servers locally also, right? You have your own cloud and
no,
you don't have. You don't have GPUs.
No.
So here, none of the use cases not involved with the customer data, right? Because all the what we put is here is the business, all the documents which belong to the security guidelines and our design patterns and those things. We actually make the rack. Right? We don't send all the mobile or customer personal data. We don't put those data yet. We didn't put anything. Yeah. Yeah. Yeah.
Especially the health data, you will have a problem, right? So I was under the impression that Dialog had servers that we can rely upon local jurisdiction, but so we don't have the GPUs now.
No, at the moment we don't have.
Right.
But
so
we are
this
trying
is
to.
something I think we need to talk about. I think how we are going to do the local data, right? Because now I have another use case where the health, especially we are trying to build a asthma registry for Sri Lanka. With another, Dr. Amita Fernando and I are actually working on it right now. And the problem is that I need to use AI, but LLM, I mean, we need to train it. So for that, I think we need to have a local situation where we need to have the GPUs in Sri Lanka. So we can't put the data into the...
So our next step is to formalize a local SLM using a GPU. In our data center. Yeah.
Actually, we have used Amazon Q license per user. Currently, I think it's continuing for 2027. No, yeah. Yeah. Token base, yeah. Yeah. Okay. Thank you.
Thank you both. So to continue our next presentation, titled Architecting the AI Native Enterprise Towards Development, presented by Mr. Lahiru Vijaysekar, Senior Solution Architect at Nagaru. Mr. Lahiru? Moving on to our next presentation, titled The Agentic SDLC, Building Software with Agents, presented by Mr. Joseph Fonseca, Vice President and Distinguished Engineer at WSO2.
Excuse. Can I get the slides? This is the previous one. Should be one. This one. Yes, I should. So I'm Joseph from WSO2. So basically, to give a bit about my background, so I mainly work with developer tooling, try to help developers to improve their development velocity. So like in the beginning of this year, like we were thinking, now the developers are changing, right? So now most of the development is done by AI agents, and then the tooling that we produce is no longer becoming relevant in the future. So we took a step back and then try to figure out, like, for the future, what type of tooling we should develop. So with that, like, we start on a new project. So I'm going to update you on what that project is. So the theme of So the theme of today's conclave is from vibe coding to agentic engineering, right? So let me narrow the scope of that, like building applications, like vibe coding applications in an enterprise. What does it take? So before I jump into the solutions that we are coming up with, I would like to explain what it takes to develop an application in a typical enterprise, right? So let's say, for example, let's take an application to capture NPS scores from the customer. So NPS score is basically a score that you give from customers' feedback, try to evaluate how you're doing in the business, right? So you can easily pass a coding agent and get application vibe coded. So you can do a web application with a database. Pretty straightforward, like 1 or 2 minutes work. But in an enterprise setting, you don't have the luxury to build application like this. So usually, instead you see a bit more complex architecture, like where you want to split into APIs and front-end web apps, depending on different practices that's set by your organization. And then on top of this, so these applications don't live in isolation. So you always have to integrate with other systems in the enterprise. For example, for this NPS score, your customer data will be in Salesforce. So you have to talk to Salesforce to get the customer information. And also, let's say if you want to send an email of asking to fill the NPS score, then you need to connect to an email server. So things doesn't stop there. So for the web applications, you can't ask your users to re-sign in to the web app, right? So you need to give customers to use the existing credentials, maybe with your support account, to log into the NPS app. So then you need to think about identity and access management, right? So if you go a bit further, you need to think about API security. So API gateway comes into the picture. And then you need to think about observability, like to detect runtime errors. And so you need to incorporate that layer also into that. So the list keep growing, right? So you need to think all of this when building an application. So then the question is, like, so we talk about vibe coding, but in an enterprise, can an untechnical person come and vibe code an app with all these complexities, right? He doesn't know about all this stuff, so that means his vibe coding in an enterprise level is out of the picture, right? Even if you are technical, it's hard to grasp all this concept when you're building an app. So then the question is, can we get agents to understand this complexity and democratize application building in an enterprise, right? So that's what we were trying to figure out. So basically, we took like a step back and then look at like a typical software development life cycle. So then we try to figure out how we can bring in agents to automate certain parts of this life cycle. So if you are following like all the talks, most people use similar patterns, like they use like different kind of agents in different scenarios. So this is what we came up with. So basically, most of the steps in a software development lifecycle you can automate with agents. When it comes to requirements, what we saw was it has to be like a hand-in-hand step where humans and agents involved to figure out the requirements. So there, at that stage, agents can do like two things mainly. One is to help users write the requirements, and also they can be able to probe the user to get the necessary information from the user as requirements. And then when it comes to the design section, so we develop special agents who knows about the organization best practices and all the complexities, and come up with like the proper architecture for the application. And then we also introduced this agent called tech lead agents, which sort of break down the complex architect into smaller tasks so that you can hand over to the coding agents at the implementation stage to go and develop. So the implementation coding agents, so we mainly use like existing coding agents like Cloud Code and Open Code, so you can switch based on your preference. And likewise, we also implement the other agents. And also, one special thing about the maintenance agent, that particular agent should be able to tap into the logs coming from the runtime and identify errors and then act upon and sort of like self-heal the application. So this is what we were hoping to build. And then this is like a really high-level architecture of the system that we built. So here, at the bottom of the stack, you have Kubernetes. And top of that, we use a platform called Open Choreo. So that's a open source internal developer platform. So that particular platform handles like all the complexities, like CI/CD, observability, so various complexities like you require from a platform is handled by that. And on top of that, we have identity, API management, and agent management. So those are like 3 different WSO2 products. So those provide the features that you need to build the applications. And on top of that, we implement our agents. So basically, for the agents, we provide 2 things. Like one is like a knowledge base with the organizational information. And also we provide the different skill set, right? For example, like how to use identity and access management, API management, likewise. So these are the places that we see, like if different organizations wants to adopt this platform, they can customize this knowledge base and the skill set based on what they need. And another important decision point we took was everything is kept in GitHub. All the requirement files and all the issues all put into GitHub so that like even humans can go in and look what's happening. So on top of this layer, basically we came up with a web app to give like a different development experience. So I'll show you in a bit. So let me show like what type of a development experience we came up with. So here, like if you want to build an application, you can start with creating a new project. And then basically you give a project name. And then you can give like a short description what you want to develop. So in this case, I'll say I want to develop an application to capture NPS scores. So then what the system does is the requirement agents will kick in, and then it will generate a small set of requirements for you to start with, and then you can use the chat agent with this, try to build up all the requirements you want. So this is quite similar to like a spec-driven development you find in other tools. So basically, the idea is this is where humans will come and define what they want from the system. And then it also has the capability of generating like wireframes to validate whether the system understands the requirements, so user can go back and forth. So once you are happy with the requirements, you can go to the next step. So from this step onwards, it's mainly automated. So basically, the agents figure out, okay, I need to implement these set of components in order to build the system. And then also it identify like the API structure, schemas, and everything. So this particular view gives a way for a technical user to come and view what the system is doing. But if you are non-technical, you can straight away skip this step and go to the output. So then basically the system takes the concept and go and implement the final application and then show it back to the user. So underneath, what actually happens is it will create a new repo in GitHub for this particular project, and it will commit all the specification files into that. And once the code is generated, that will be also put into the GitHub repo. And all the tasks that coding agents will do will capture as issues in GitHub. So basically, what it does is it will create a issue with the big context and then hand it over to the coding agents to implement. Given the time, I'll stop from here. So basically, this particular project is open source. You can go and try it out. The repo also has like a nice demo video, so you can see what the system does end to end. Questions?
So your agentic orchestrator runs inside Kubernetes or outside of the Kubernetes?
It's inside Kubernetes. Basically, it's in top of Choreo as well. So we have the control plane. So this one, so we have like a setup script. So it will do all the installation for you.
We can test it out, right, here?
Yes.
Okay.
So it has like all the documentation.
Cool. I have one more question. So this is generally related to open source development. I'm kind of a like small open source developer as well. So I have seen there are multiple problems coming out. So I just want to know your perspective, how these things get resolved. So one is a random dude which is non-technical in Sri Lanka can create thousands of pull requests to open source repository, right? So it will be very tedious. Anyway, the maintainers are having a huge load of work, but then it will create another load of work. So that's one of the thinking which I'm having. The second one is, okay, if we build really good agentic system to build the open source software, do we really need any pull requests and open source developers at the first place? So then, so it's like contradicting. So I just want to know your opinion and how you see how these things get evolved in future, generally in open source development. So my question is not perfect, I know, but
yeah. So the way I understand it, like, so for our reports, like recently we are getting pull requests like from students as well.
Yes.
So then, so when you look at the code, you know whether it's a generated one or like a handwritten
yes.
one.
Is there any automated way where we can just block off and cut off all the?
So the idea is you don't need to cut off as long as you can validate what the code segment is doing, right? So we ourselves is now writing most of the stuff with coding agents.
Yeah.
So we can't like put aside the PRs coming from outside. So it's about like improving your ability to validate what you're doing, right? Like no one said in the morning, what you get, whether whether you can validate it properly, so then you need to build up that capability. And what's the other one?
The second question was like, would we need open source contributions at the first place because agents will be developing everything?
Yeah, like, so the way I see it, like, even though agents build the system, what you build is still in somebody's head, right? So if you take a look at identity and access management, so somebody who is deep into that particular field know like all the scope of that work. So someone else can't just randomly create a product like that and use it in their system, especially something related to the security, right? So that that knowledge is still there even though the code is generated by it. So I think still the projects will be there and flourish in the future.
Right. Thank you.
This question actually related to our company as well. So our management invest a lot of do a lot of investment on AI, right? But they, in the meantime, they want to get the outcome from this, right? So we have a big question: how to measure the productivity or the outcome or gain out of this agentic or AI investment. So assume if we are going to onboard your products into our ecosystem, and how we can prove the productivity, or it can be quantitative or qualitative, like matrices like DORA matrices or sprint velocity kind of things. So how can we measure? How can we? Is there any benchmark or productivity gain we can get out of from this AI solution or your platform, the agentic platform? How can prove it to the management? Is there a way?
Yeah, okay. So this is like still we are starting this out. So what we are trying to do is dog food this, like to implement like all our internal platform, internal applications on top of this. I think the value is like, so if you look at the organization, there are like one way to look at is if agentic coding is not there, there'll be like a lot of applications you wouldn't do, right? Because of the effort that you need to put in. But if you have something like this, that will enable like other people who are in your organization to build what they want, like to get more functionality out of this. So with that, I think that can be like one measure, like what more work can you do because of this? So yeah, the other things, like we are also still figuring out like how to measure that.
Interesting presentation. So I have a hypothetical question. So agentic engineer is designed for a existing application, right? Existing enterprise, right? So I'm curious, so the hypothetical question is, how would you design it differently for, let's call it an AI native enterprise that has emerged after AI and therefore would design its business processes and organizational processes knowing the developments in AI as opposed to a pre-AI enterprise?
So the advantages that I see mainly comes from like the underlying platform, like to start with, like we talk about this open courier, right? So that's a readily available platform for any enterprise to start building that thing, right? If you don't use that, then you need to build all that from scratch, right? Even though if you have AI agents, you need to have that know-how to do that. Same goes for identity management and all those stuff. So basically, what I feel is any organization needs to come up with something like this, whether they want to use agents and develop that or adopt something that is readily available is the value, basically. Did I answer your question? Okay. Okay, thank you very much.
Thank you, Mr. Fonseca. A really important angle where this technology is heading. Next up, our presentation titled Atlas, Adaptive Tool Library and Agentic System, Tool Management for Autonomous Coding Agents, presented by Mr. Praveen Dhananjay, CI AI Engineer at Synopsys.
I'm Praveen Dhananjay. So I'm from Synopsys, and we are building a platform, adaptive tool library and agentic system. So main focus is when we are getting to the industry and enterprise system, we face LLM agent have really good limitation in two main areas. One is the memory. So when you have large repo with thousands of millions of lines of code, that agent cannot understand what the hell is it, and cannot understand the architecture. Sometimes some solution have multiple repos, so they cannot go through all of them. So, and also when that agent understand particular information, that after one session, that information goes. And also there's another aspect of things. That is the main interesting point. So, as also when we are dealing with a large stack with sometimes we have to deal with operating system level, sometimes we have to deal with hardware level, sometimes we have to deal with network level. There are so many aspects of things. When agent understand particular solution, particular system, tool, and how to debug, how to deal with them, sometimes they need a different tool to grab particular information, that kind of tool and that kind of different capabilities need to be there. But in reality, agent learn things, but do not have any way to continue that learning in and reuse that particular learning. So and if agent produces some valid capability, they have nowhere to sandbox and test it. So now we bring a solution. If you have a large system, how we create an agentic system that adapt to our solution and build our system more effectively, more efficiently. So in the current state of our research, there are two main strategies. One stage is fully autonomous. There are a swarm of agents that are adapt to our solution by itself. But it is a really tedious because it consumes trillions of tokens and really hard reinforced learning problem. Some companies are doing that, including Synopsys also. So it is a really hard problem. And there's another stage. We provide a supervised agent. So that supervised agent coordinate. By doing that, we can reduce a 1,000-fold token reduction in there. Because that supervised agent coordinate those subordinate agent and doing the procedure. But these also have a limitation. After session, we don't have that particular session information, how that adapted agent, how we save them. That kind of problems are there. So we introduce a third stage there. Agent as a paradigm, that is where our Atlas platform came into play. So we introduce a small thing called tool library. In there, we provide a couple of capability with a couple of capabilities. So within the system, so it can produce, it have different building blocks to our system that are especially built for our system, have a supervised agent that coordinate and supervise our system into long run and produce our system correctly. So this is our tool manager. It needs to have a couple of main principles. It needs to manage our tools and things, and if it develop a particular tool for particular solution, it needs to verify and save it properly. And also, if someone asks, some LLM agent asks for particular tool, network tool or some kind of debugging tool, it need to be efficiently give that tool back to that particular platform. So, and also, if someone asks a tool that can be produced by combining a couple of small primary tools, that kind of operation also need to be there. So, we introduce a life cycle of things. So, first, our main platform request to our Atlas platform. We need a specific tool or capability. First, it analyze the requirement and take a decision. Is it possible to create a tool from our existing one? No. We can create a new one that kind of take the decision. After that, develop the tool, and then validate the tool. And if it is correctly validated and functionally correct, it need to be saved. That's the primary thing. So it also has some couple of routing. So we enforce our system to reuse as much as the tool. And then if that particular tool is need to do adaptation, we can do adaptation in the second stage. The last option is the tool creation. So we as much as possible time, we are avoiding that to that LLM because that costs some, but it also serves interesting things. So next, we are looking at that sandbox, because if LLM builds some tool for itself, it need to have some secure ground to test their tools. So this is a simple architecture. So it have a Docker-based environment. So inside that, if it have some OS level implementation, so it can do OS level changes, because there can be crashes happen. So rather than sacrificing our own environment, we put that Docker-based environment so they can sandbox in that solution. So this is the overall one. What our application integration. So our client is there. So then client have that VS Code-based extension and connect to Atlas. In that this presentation, I'm focusing on the tool manager only. So there are some other interesting areas with graph-based, knowledge-based. So I'm not talking about that particular area. So this is the overall architecture with the component. This is also an overall architecture. Then this is the UI. We have graph-based, knowledge-based. So this is for getting the knowledge from the entire code base. So we can graph the entire platform, how all the component connection. And we have two more components with a tool manager and the chatbot interface. And this is a screenshot of the tool library. So we can see different tool implementation, how these tools are there. We can also see the usage. If it is a new tool, we can remove these tools, that kind of features are there. So next, depending on the different prompting, we have different result and score. So first we evaluate this one. So different prompting strategy. So in that structure constraint is the one we receive a lot of scores in our experiment. So that is the one we are stick with. And then this is also that scores and different time it consumed to work it. So that is the one. Then we compare our platform with different agent, and we use on-prem agent. So we have to do an apple-to-apple comparison. So quad-core LLM is the one we are using for our testing. So when we have a small code operation in a human evolve, it has some couple of small code agent tasks. So in that case, our Atlas platform have better performance compared to rest of them. But when you are getting to some complex operation, some of the cursor and GitHub Copilot are providing superior performance. So, and also we have some robust score. It also have scores in everywhere. And also some efficiency metric that also have some top tier performance for Atlas, and also functional correctness, how it functionally produces the code, and also that code quality. When in that scenario, we start to see some really interesting pen, because that open source SWE show really good result. But thing is, it produces a code that is quality code, but it also secure code. All the security guidelines follow, but it is not functionally correct. That kind of weird behavior start to show. And we start to investigate what is happening, why the benchmark results are really good, but it does not show any better things. In there also, that open source show better one compared to, in some areas, not others. In our one also have a good result and apply on our industrial things. So this is where we came into place. Our solutions show better performance in benchmark, but do not have better result in the actual world. So we do some investigation. What we come up with is, most of the LLMs are trained on industry standard benchmark, and they know the exact solution for that particular benchmark. So that is why most of the LLMs are better on benchmark, but not in the real world scenario. So this is a really interesting area. We are currently doing some of the research on that, how to tackle this one, because in the benchmark it is a really good one, but when we are going to our enterprise system, it cannot resolve the thing. So we are dealing with not only our solution, we are compared with other platforms also, that Cursor, GitHub, Google, all of them are lagging behind. So we are also in there. So this is also an example. In our scenario with our code repo, our private code repo, they have no clue of how to resolve that. So this is the status of our project. So if you have any question, please ask. Sorry?
So for the human eval benchmark, I think you had the OSS GPT OSS number, right?
Sorry?
So in your benchmark numbers, human eval GPT, you had OSS number. Go back before. Yes, right? OSS means GPT OSS, right?
In there, we are only selected couple of only selected benchmarks. So
okay, you are only doing a subset of the human eval.
Yeah, because only related that code tasks. There are some couple of human eval have couple of code related tasks. So they are the only one we are focused on.
Human eval is competition programming. Okay. So it is a subset. So maybe you took a harder subset. Okay. So the other comment is that about the working on the benchmark and not working outside. So there's a benchmark called live code bench. The live code bench, basically, its problems are timestamp. So you should only run it. So basically, you can look at the model and find the problem so that the model has not seen. Right. So then actual numbers goes down a lot. So, yeah.
That is a really good comment. We will focus on that. Thank you, everyone.
Thank you, Mr. Dhananjay. Really appreciate that perspective. And that wraps up our presentation block. And we'll be moving on to our panel discussion. Please bear with us for a couple of minutes while the stage is being set. We've heard how things are built, scaled, and applied. Now we move from individual perspectives to shared dialogues, the panel discussion. Joining us today are 5 distinguished voices spanning industry, academia, and applied research, each shaping the direction of this field in their own way. To guide this discussion, please welcome back to the stage our moderator, Dr. Ruwan Veerasinghe.
Thank you. We tried hard to make this the four panelists to see each other, but it was really hard in this small space. So 2 panelists will be on one side and the other 2 will be on the other side, and I'll moderate from the middle. So let me invite in no particular order Dr. Sankalpa Gamwarige is a digital transformation leader and managing director and senior leader at Nagaro with more than 2 decades of experience across engineering, embedded system, technology leadership, and enterprise transformation. He has also held leadership and advisory roles connected to TRACE, the National Innovation Agency, HNB Assurance Zone 24/7, and the University of Moratuwa Ecosystem. For this panel, he brings a practical enterprise transformation perspective on how organizations can build disciplined AI adoption, technical capability, and talent pipelines. Let me ask Sankalpa to join us and thank him for coming from a very important function. Thank you very much. Let me also invite Dr. Srinath Pereira, who is Vice President and Head of Research at WSO2, with deep experience in software architecture, distributed systems, data science, and research-led engineering. He's a co-founder of Apache Axis 2, a member of the Apache Software Foundation, and has co-architected systems including Apache Airavata. And Siddhi Complex Event Processing Engine. He brings a strong rigor and architectural lens to the discussion, especially around moving from experimentation to reliable, scalable AI-enabled systems. Sankalpa. And we also have Rukshan Jayaratna, is a product management leader focused on building AI-native products with nearly 2 decades of experience across product management, engineering, program leadership, and strategy. His background includes leadership roles at organizations such as Pearson, London Stock Exchange Group, IPAX, IT Consulting, and Mazarine. And he is associated with the Colombo AI Conclave. He is the founder of the Colombo AI Conclave. He brings a product leadership perspective on how teams can move beyond vibe coding towards measurable outcomes, disciplined experimentation, and agentic product development. Rukshan. And finally, we have our keynote speaker, Nuwan Senaratne, who was probably introduced earlier, but I will introduce him in the context of this panel. He's a computer scientist, investor, and consultant focused on practical AI, data systems, and product engineering. He previously spent over 8 years at Facebook Meta, where he worked on large-scale AI and ad engineering systems. And he holds an MSc in computer science from Stanford and a BSc in computer science statistics from University of Colombo. His perspective is especially relevant to AI native workflows because he bridges production scale AI engineering, data infrastructure, and startup product advisory work. Please welcome Nuwan. Okay, so to make this panel a little kind of not very what do you call objective, to make it a bit subjective, I have asked some of them to play certain roles, right? And so 2 of them I asked to play kind of bullish roles in terms of vibe coding. you know, and that's the way to go. We don't need to do this, you know, all this software engineering and all that. And one of them to kind of be more skeptical, bearish role. Let's see whether you can guess from their answers at the end who these people. And of course, I also asked one of them to be kind of an ombudsman, you know, who will kind of try to see both sides and help us with, because the conclave is a bringing together of minds, discussion, sharing, best practice, and also we want to take away something from this. First, to make a kind of a statement about their take on this whole vibe coding and agentic coding from those perspectives. So sometimes what they say may not be exactly their point of view, because they are kind of pushing a particular argument as far as it can go, but it will also give you a hint of who is bullish and who is not, who is bearish, right? So shall we start at my extreme right with Sankalpa? I have given them each about up to 5 minutes to say their piece, their manifesto.
So thank you very much for inviting, and it's a very interesting topic you all have selected, very timely topic. I think I have to wear this proposing and opposing part in two different organizations. So one is when you are part of a company who is extremely focused on engineering part. I think we want to make sure our engineering business is continuing in this game, so how we are adapting. So in that context, I think we call this entire story as AI in SDLC. Artificial intelligence in software development life cycle. But I think there are Srinath and plenty of other people. I would not, I think, wear my Nagaro hat here today. But last 2 to 3 years, I have been selected for do some sort of a big transformation in brick and mortar type of businesses, especially in financial industry. So I have to sit in the board. So in the board where a lesser of digital adaptation happen, I have to push a lot for it's a local company, local listed company. I have to push a lot to our teams, right? Who was always giving excuses. No, they are totally dependent on the vendors. So whatever things come, they first ask vendor. So vendor takes them a ride. And apparently, they spend a lot of money and not much of that sort of outcomes and results. So for them, I think I pushed more from rather than, okay, I pushed them to, why not you guys try to, because you all are the one who knows your domain. Why not, then they say we don't know programming and all. So that's where I pushed them a lot for this vibe coding space. And interestingly, in addition to that, our family, we had another, I think, doctor also knows, Chandramali Genetic, our family startup company is there. So it is into genetic, I think, testings. So my brother-in-law, he's not a programming guy. He was a systems person. He retired. And one thing we want to develop was what is called lab management system. So interestingly, last 4 months, he from scratch He's not a traditional program, but he has done programming during his university time. He was actually the guy who was deploying all London Stock Exchange, all these things. He's a guy who was actually integration specialist. So not a programmer, but he built from scratch the entire lab management system there. So that was a remarkable achievement. Who supported a little bit? His daughter, who is on the first year in a local university. So she supported not by programming, but both of them, and they had a lot of other challenges, right? But managed to get this lab management system. What I found is these people had a lot of, I think, enthusiasm and courage to do that. They were not programmers. But same time, I want to tell you, the company, now this company also, I play more like a board member into a family startup, right? Whatever their transformation investments, there I play the role. But the bigger company, we have a lot of money. It's a billion. It's on the 60th place on the Sri Lankan list. And the share price recently doubled with Solid. So strong growth. And it's a very successful thing. But unfortunately, they are good friends of mine from my own university. My batchmates are there, but they are struggling still because they are still not have bought into this vibe coding concept. So a very simple thing is, if somebody who is having a passion and belief, not a programmer, but want to build a system, who knows what to achieve, it is a right time. And the barriers to entry and barriers to get the access to the right software for you is being totally taken out by vibe coding. So with that remark, I'll pass it to you.
Thank you. Rukshan, would you like to have a step next?
Okay, so I'm going to kind of take what Sankap just mentioned to more first principles, right? So when you have a problem, who's the best person to solve the problem? Right? If you have a problem, who's the best person to solve the problem? The best person to solve the problem is the person who's having the problem, right? Because nobody. You have to get it driven, right? But the technology is coming to a certain place where the problem and the solution, they are in two places, it's coming so close now, right? So as what Sankapal described, if you have the problem and you need software for it, you probably can solve it as well, right? With the vibe coding platforms out there. Particularly if the solution is particularly for you. Imagine if this shirt I need to tailor this shirt. If I can tailor it myself, I will be the one who doing it in the way that I want, right? I need to fit into somebody else's agenda because I can't tailor it myself, right? And people who can really cook, actually, they don't like anybody else cooking for them. They like to cook it themselves, right? So similarly, if you can actually solve a problem, vibe code is now the problem is now as an industry what we are facing is that now there's the problem and the solution. There were so many professionals in this layer, right? So there was a software engineer, there's a business analyst, there's somebody who's write the requirement. Now all these professionals don't know the problem. So they need to ask somebody the problem, right? So particularly in Sri Lanka, we have so much of a good background on engineering, right? But our experience of technology coming to the people who can solve problem is very little, right? Any industry, architects, medicine profession, medical profession, the people, UX development, all that. That's not needed. If I have, me as a product manager, if I have a solution to be offered to the engineering, I can mock it up and create a working solution with actual connected APIs, everything within a day, most likely in 5 minutes, right? Most cases. So that's where it is hitting now. I have moved to it, but I'll stop there. Right.
Thank you.
Yeah.
So, yeah, it reminds me, I'm from language processing, and many years ago, many eons ago, people were developing these speech recognition systems, and IBM had one of the guys who was right at the top. And the people who know about language are linguists. So we ask them how language works and all that. And then at some point in that evolution, they became an obstacle. So he is famously quoted as saying, every time I fire a linguist, my recognition rate goes up. So it was rather kind of a nasty comment, but so we are in a stage where things like that kind of disruption happening in software engineering. Srinath.
Okay, so let me start by saying, so the benchmark, so there are a lot of benchmark on code generation on this topic. They are overrated. So they are overrated because, so there are two parts. We talk about human eval, that's the famous benchmark, but then there's a new benchmark comes called live code bench. Basically, it track contamination. So basically, the LLMs have seen these problems and know the answers. So the moment the live code bench comes, the numbers drop by like 40%, right? And then actually there is another benchmark called SWV Live. Nobody report against that. You can go and think why nobody bother reporting against that. So okay, so where the LLMs are right now, it's a bit overrated what they can do, right? But there are a lot of work going on to do better on top of those, right? So like for example, when you are given a prompt or problem, you can create like 10, 100, sometimes thousands of code for this, right? And you can generate tests, you can run them, and you can look at them and see which ones agrees, right? And so you can pick better solutions, right? And so I do research around this. I'm just kind of running through what different papers did, right? You can basically generate tests. Like there are different ways to generate tests. You can generate sample data and you can run through that. There's something called simulation. You can give the code, you can give the data and ask LLM to critique about that. So there are a lot of these things happening. So it's like one branch. So there's a lot of good work happening. So there's a different branch to generate code using formal languages. So that basically means, so there's a language called Daphne. So you generate the code, you can prove that given the precondition and postconditions, the code is correct. So the Daphne, very recent paper, they got about close to 90% on human eval. So that is coming. It is coming too. So it is going. So okay. So that is there has been progress and more progress will happen. But so the one big problem of all this thing is that people think code is the value. Code is not the value, right? So there's a funny comment from a very famous programmer. Apparently his manager tried to put a KPI on how many lines he write. What guy had done is he had gone and refactored the code. Every day he's reporting, I removed 5,000 lines. I removed 10,000 lines. He said like after a week, manager took off the KPI, right? So there's that. So it's not about the code, right? It is about the risk associated. The real question is, if there is a bug, who is going to debug it? If I have a code and if I put it in production, if there is a bug, who is going to debug it? Or that's if it is a reversible, this nice kind of a bug.
I mean, if it's this bad kind of a bug that after 10 years you figure out like 50,000 people diagnosed wrong, okay, so somebody will go to jail. So who decided to put it there, right? So that is the key question. So if this whole thing actually work, I have a great business idea. Go and basically create a business where the customer will give you a use case. You give him the code, but you take the liability comes with that, right? You will be rich. You will be rich if you can do that. But, I mean, doing that without going to jail is not easy, right? So, okay. So that is, I mean, that's where. So so I was at ACM CAIS last week. So there was a Google talk. So they were doing a lot of this, but they had kept the code review part, human code review part. And he was basically saying the problem is they get overwhelmed because I mean, you can generate code, but the reviewing is not hard. So they are trying to use AI to do code reviews, etc. So there's multiple angles. There's a lot of work going on. So the real challenge, actually, on average, the code AI would be more correct than humans on average. I think we are even now close. We will get there if not. But the real problem is when AI get it wrong. So I mean, I explained like you generate code, you generate tests, you do this feedback loop, complicated, etc. After you all do those things, and when it is wrong in a way that that will like get your head in knots and take days, weeks, months to figure out what the hell is going on. So that is the real challenge, and it is who is going to debug it when it goes wrong, and how you manage that risk. So, the final comment is that actually in the hand of a thoughtful developer who do this very carefully, vibe coding can work. But let me ask you a quick question. How many of you are driving? Can I see the hands? Okay. How many of you think you are a below average driver? Okay, so then the 93% of people thinks they are above average driver. 93%, right? So this is the challenge when you bring in the vibe coding, right? The quality is not a technical problem, it's a human problem. So that is the real risk. I'll leave it there.
Thank you. Thank you. Okay, I'm not going to ask Nuwan for his, or should I? Because he's already talked to us in the keynote. So by the way, please get your questions ready, things that come up during this discussion, during the responses to the questions I have prepared, so that we can have a meaningful discussion. So the first question to the panel is, many people suggest that in this era of agentic engineering, code is increasingly viewed as a kind of a passing, transient thing. It's no longer important, while specification and domain models become the kind of the durable sources of truth. What is your response? Let me start with Rukshan.
Do you mind if you rephrase the question again?
Okay.
Yeah.
So code is no longer important. It is the domain and the specification become the really important.
Can I bring it down to whether a software developer is important?
Okay.
Because that is where most of the issue is. Right? Code is going to be there anyway in any form, because code is going to be there in, sometimes it could be even natural language, right? Code now, most of the...
Little closer, please.
If you, for example, experimented with OpenClaw, right? Code for OpenClaw is in English. The instruction is in English. All the .md files are in English, right? Soul.md is written in English. Claude's soul.md is written in English. So that's code. Code is going to be there.
This is Claw, not Claude.
So Claude for Solot.md as well as OpenClaw Solot.md all are in English, right? So if you look at those files, those are in English. And the direction is maybe even vectorized databases might not be the source for LLMs to source, sorry about that, I forgot to put it on mute. Would not be the source for information. It could be first source might be English, so the code is going to be there. But the software developer, that is our question, right? If I would put it like that. So a software developer, as I mentioned before, is best useful when you have domain knowledge of a certain domain. So this problem is even for United States, right? If you have a software developer who's purely knowledgeable about software engineering, not valuable. If you have to tie it up with another domain that is in your liking, right? Because it can't be something that is forced on you. That is not going to go away. That is going to go more and more. That domain is going to become more and more beautiful as well as more and more interesting, right? Vice versa is going to happen as well. Domain specialists who has software coding background, when I say coding background, it's even just writing an instruction for a large language model. That is coding. Domain knowledge specialist, dentist, or a medical profession who has a knack on writing an instruction to an LLM is going to be an interesting thing to do later on, right? So if I were to just say coding, code, I can't even say what is coding now, because coding can be anything. Because when I started coding, I mean, D-Base 3+ and Q-Basic and all that. None is there now. Now it's more English now. But obviously there are coding in the hardcore level. All the hardware level coding is going to be there. That's not going to not go away, right? All the coding that NVIDIA is doing with their platforms, that's going to be there. But if I talk about more application software here, right? Coding is not going to go away, but it's going to get more interesting, I would say.
Yeah. By the way, hopefully you kind of are figuring out who's bullish and who's bearish in this whole thing. Let me ask that same question about this role of the software engineer and the fact that, you know, it's the domain and the specification that is important from Sankalpa.
To answer that question, I think I'll go back to my own career. So I started more as an electronics engineer who electronics meets software. That's where I started programming the assembly and C, and then only learn Java and all, right? So and being more of an embedded designer. So that particular space, good old days, I think we had to have human agents who can very nicely map into these very specific structured things, right? Humans have to use that. It is a tedious thing. We were spending more and more time in that manner. I can still remember when I started, I think first I touched computing, that was in 1988. And GW Basic and x86 assembly I used just as a geek. But then more after graduation, 2002 onwards, I think more into embedded area. Our task was to, I think, get into this very low level thing. And then we quickly started to adapt operating systems into embedded systems. Like one of my first assignments to port even Linux into one of the US payment terminals. So likewise, more into embedded. But that particular track itself, we found initial days, our hardcore engineering, we call the hardcore engineering is that nerds who knows that certain numbers, who are not much interested about human problems. They are more happy about what is the voltage drop or what is the assembly line code. I think that sort of people we want, early days we had to have a lot of them. Then what happened was we started to put them into some sort of libraries, right? And we started to reuse libraries. And then platform developers, I think, for example, hardware, say ARM platforms and all, they shipped all these things. And then our teams, right, I was part of Atpos, which was later acquired by Symbol and which was acquired by Motorola, likewise. That journey, we found our initial days, both bring up to writing the bootstrap code to all these are tough things, but we were having a lot of fun, the value started to diminish because the guys who are sending the hardware, they've packaged all these things. What is they been expecting, even for a hardware guy, now to solve the problem? Because end of the day, people are paying for you to solve their problem, right? So they were expecting us to give that complete experience. So that's where even the more of, now that embedded team also, more of guys started to ended up programming in Python and other languages, writing about more high-level business solving problems. So what I was telling you, that was the transition. Now we are in a similar another transition time period. There we had the compilers to or the assemblers, all these things. They are doing a very structured, right? Very structured, deterministic conversion. Now with AI, what it's all about, we have introduced some sort of humans are fussy, right? Again means humans always they can turn their tongue. So because when pressure and all these things come, there is no 100% deterministic answer to us. So that was what the AI was trying to build, and they were quite very interesting, got successful with the paper of attention is all you need, right? How humans got this. It's all about that probabilistic game. Now that particular thing we developed, we suddenly found, the guys who build software, we suddenly found that can be used because the biggest amount of money was going to software engineers themselves. Now most of the mediocre things they were doing, which can be done, I think they were not say do this small change. What happened was our human engineer, they say no, not today. They're demanding and all this. These problems are 100% eliminated with the coding agents. But the role of humans in the loop is still there. So AI can build, but humans need to take the responsibility of these systems. So with that note, I'll pause it. I am pretty sure that my entire story could have been explained to you. What is the new software developers or the programmers' role?
Yeah, Srinath, your take on this.
I defined the code. So actually, I think, so now if you think about what we run, if you write Java code, it gets compiled, then go to the bytecode, then go to assembly, etc. So there's many level of code, right? But what we go and put to the GitHub and protect is what we wrote. That's the earlier world. In this world, I say code is the human's input somehow encoded and protected. So it may be the prompt and then somehow capture all the feedback that come, all the test definition. So that is I think just thinking that getting excited that you are getting a lot of Java code is not the right way to think about it. And so the second thing, I think I'm pretty much very close to what Sankalpa is also saying, that it is, so okay, the reason I think the challenge with wipe code is that it kind of gives the license for the developer to be fluffy about it and say, I mean, I told it and it's supposed to work. So the end of the day, okay, it is only a human who can hold responsibility, right? So the machine cannot be responsible. So the way the law works is that if there's a human, or I mean there's action, if a human do it, okay, you catch and put him in jail if it did something very bad. Or if a robot or some AI did something wrong, you put the guy who, not necessarily wrote it, the guy who decided to deploy it. Right? So I personally believe the way to enforce quality is that when a bug happens, you have to go and find the guy who did the code review and ask him, explain why it goes through you. And he is responsible, not the guy who wrote it. I think it is the same model that we need. So it's the end of the day. It is the guy who holds the responsibility. It doesn't matter whether he writes code or whether he create fab or create whatever, or some quantum thing that magical. It doesn't really matter. He has the confidence it works and he takes that responsibility. That's what matters.
Thank you. Yeah, it reminds me of this car that is being advertised a lot, that you can say park and it parks. But when it parks, if it hits something, you can't tell the manufacturer that to pay, right? You'll have to pay, right? If there's no one in the car, I don't know. That's a different...
So the insurance can solve some part of the problems, but yeah.
Okay. Thank you. Yeah. So, So then there is this whole thing about speed. We know that the big kind of benefit of this technology is that agents don't get tired and they can work 24/7 and they don't ask for, rights for now. They don't ask for. And so, what is so how in that whole thing, humans are really messy, right? Humans are messy, right? So in that equation, countries like Sri Lanka have always managed to, because our coders were really good and they only asked for a small price. But now we have, but they get tired and so they have to have holidays and all this. Now in this world of agentic coders, they don't get tired, they can work, and we can ship much faster. What is the, what's wrong with saying, let's get away with all these human coders and give everything to these agents? We'll start with Srinath here.
Okay, so two things. Actually, there's a pretty famous paper done by Microsoft Research on, it says, it's about software engineering. It says, I had a good day. So this is like, this Microsoft Research, they go and I think they interviewed 800 developers, basically asked like, what was your good day, what kind of you were doing, etc. So it came out, 15% of on a good day, they were coding 70% of the time. On a bad day, they were coding 15% of the time. Rest of the time was spent on other things. It's like talking to people, figure out what needs to be done. So there is that, right? So the thing is, if you build a complicated enough system, so there are like two kind of cases. There are like well-known, there are some systems that, so let's say some website, or there are some systems that we know how to do it, we have done it like 1,000 times, and I mean, due to some reason, we do it again. So those, there's not a lot to be thought. If you ask LLM, will build it, it'll work. So I think there's nothing to worry as much, right? But there are, but the other systems are a bit more complicated, right? So repeat the question.
So the question is about the speed at which we can deliver these versus the architectural rigor, So there is like a massive benefit in using agents because of this.
Sorry, I lost my throat. So I'll come to the second and I'll come back. So the one side related to this is if the AI can do code very, very well, what will happen is it will be like math, right? What I mean by is like math is very important. We learn it. I mean, everybody knows, fine, but it's very hard to hire a math company because you don't get paid for doing math because it's like this part of this taking the code and mapping to the this part of taking the problem and mapping to the code part, you don't get paid. You get paid for problem solving all these, right? But so you can't make money by being just doing code. So that's the first part. So the second part is, what I lost on the middle is that actual this code part is 15-17%, right? So basically humans are doing the other thing. And the most important thing is that when you do these complicated things, the complexity is when it touches the humans. I mean, when complexity is the information theory, etc., usually we build a theory and solve it. But when it touches so it is the humans who understand the human, right? So it is a one way for AI to think of, understand the motion sickness, or how much you, what you feel if your child is sick, etc. It's one thing to go through the novels and try to visualize it versus how a human feels. People usually feel it irrationally. Only human can really understand those requirements. So the humans will keep doing that while this pure code thing will melt away. You don't even, you might not even know that it goes away, right? It will go away.
Okay, so a lot of the talks talked about these things, this thing of what humans do in this other time, non-coding time, and many of them had different kind of artifacts, either knowledge graphs or wikis or some other way of capturing that knowledge. So can I ask maybe Rukshan about how can a agentic system capture those things that are not explicitly stated but happens in, I don't know, human interaction and reading and other things?
Yeah, I mean, in the practical sense, two things, of course. I mean, generally, even though you wouldn't want us to reveal where we are going towards, one problem that is there is that the token cost, right? So all the platforms that are there are geared to make you use more tokens. Claude is geared to make you move more tokens because couple of days back in X there was a nice photograph, or rather a GIF, where it's titled as me trying to use Claude to rename a file, right? And what the GIF was, where there was a guy who was trying to light a cigar with a blowtorch, right? So that's where things are now, because all these platforms really want you to lose yourself in tokens, right? Now, I paid myself for Cursor for about a year. Every month, about second, third week, I lose the rate limits. I have to wait another week until this thing refresh. Now, of course, from my office I have a Cursor. Right? Also, now if you use Claude, for example, for every bit of a thing, I calculated 30 tokens is how much is a malupam, right? So my God, I tell something, there's about lunch gone, dinner gone, buffet gone, right? But my company is paying for that, right? Now the problem there, engineering has to come, is to figure out a way to make this lesser, especially for countries like us, right? So if you can build a system where this has uses the optimal best models for the specific things and uses a local model for you to do the basic things. I'm imagining something like a UPS sort of a thing where you plug into your system, which runs a local model, which can be kept in a agriculture location, right? So that it uses intelligence locally, local model, right? So I might not have answered your question directly, but I also lost my track while like him. So this is not a solved thing yet, right? But we need to find our role in it and go there very fast, right? Because these LLMs are not going to go away, AI is not going to go away. Very capitalistic Western society is not going to get away with this also, right? The US model is where the richer becomes richer, the poor becomes poorer, right? So there, the richer would actually push for this, because there, more you automate things, lesser you pay tax, and then you actually can make more money, right? Because in the United States, the wage earners pay the taxes, and the capitalist society don't. The $1 trillion people, they don't pay taxes, right? They pay like 8%. Wage earners pay like 35%. So they'll automate it as much as possible and pull it up the chain. So we'll be caught in it as a third world, right? We need to figure out a way how to get out of it. Local models and all that is going to pay back, but we'll still have to use their models to pay for the bigger things, right? So all of us have a role to play. Please find your role. Don't, because this is a wave, right? And you need to ride the wave. If you don't ride the wave, you'll be left out, right? So when you're riding the wave, you'll get support from people who are riding the wave with you. Don't let the wave go far away, and you can't, it's much of a distance, right? You have to be very current, know what's going on, and find your role in that solution, right? Then you'll be somebody who will be useful for the society. And it's sort of like a in statement thing, but I hope it's fine that I mentioned that.
Rukshan is kind of crossing on to the other side, but that's okay.
Yeah. But yeah, I mean.
Sankalp, you want to respond to that?
Any particular thing you would like me to comment on?
Actually, I had something coming up for him because there are also a lot of academics here, and I think a critical question is, I think it was also asked during the presentation on what does this mean to what we teach and what we assess. So if you can start with some ideas on that.
Yeah. Before that, could I make a quick comment on
the other one?
So
yes.
you mentioned speed, that AI is faster, but then Rukshan also brought up the thing about cost. I think that has got lost in the conversation. We don't really talk about cost. So I work with a lot of startups. I invest in startups. And what I see is about maybe 90% of startups built on top of AI, their business model is not going to work if the AI companies pass on the actual cost over to them. So at the moment, because of the competition between Anthropic and OpenAI and Google, the costs are artificially being kept down. But all of these business models will go away once the actual cost is passed on. So I think that's something we should really keep in mind when we build on top of these platforms. So that's one thing. The other kind of related point is, I think, again, we get really kind of lost in the hype around LLMs and things. We forget that there are alternatives to them. I mean, the obvious one is the small language model, but then you also have things like world models and JEPAs and things like that, which are actually much lower cost and seem aligned with the problem it's trying to solve. So Rukshan kind of brought up the kind of the meme of renaming your file with Claude Code. Like, you don't really need to put that sledgehammer to solve such a simple problem, but a lot of other problems, you are throwing way too much AI power at a disproportionately small problem. So that's something we should keep in mind.
Absolutely.
Yeah. So back to the question: should I go academia first or industry first?
You can pick. Yeah.
Yeah. So I kind of adding on to what I said during my keynote. So I think we should separate out two things. There's the learning, teaching learning bit, and then there's the assessment bit. I think the teaching learning bit is kind of an easier problem to solve because it's kind of less controversial. The assessment piece is the one that's kind of more controversial. And I think that's where also the gaps are. And so I think we need to be very carefully assess, if you take academia, what is an undergraduate degree for, and align assessment with those specific goals. So for example, most people get an undergraduate degree because it's a stepping stone to employment. And so it needs to be aligned with that. There'll be others who will continue in academia that needs to be aligned with that. And then there'll be kind of still like a very small minority who probably like learn for learning's sake. That's like another kind of a goal, which you might argue was the original goal of education. And maybe in a world where AI is taking a lot of employment, we need to go back to that. So I think very few people in industry kind of sit down and think and ask the question, okay, what am I actually working for? And similarly in academia, okay, what is education for? I think we need to go back to those first principles. Otherwise, we just kind of get lost in kind of the day-to-day things. I think something that I see a lot, again, both industry and academia, in how they use AI, they're actually not using AI to solve the problem. They're using AI to make sure that the organization survives. And in many ways, they are losing sight of the problem. So for example, when an organization uses AI to kind of automate their processes, they are actually trying to preserve the existing processes, but with kind of an AI shell. Like that doesn't necessarily work, and that's not going to be competitive, and that might not really solve the problem that they're trying to solve.
Yeah, I like to come to, because these gentlemen are not hiring our students anymore. So this is a hard one. What do you expect from a graduating student?
No, that's a very interesting question. I think we, again, like the education, even the businesses, while business is flowing, right? Time to time, we have to go to the first principles and ask certain things. Then I think all these things. So while we as a companies right now, for example, Nagarro, the total headcount moved to 20,000 plus. Right now, every day, I think we are slightly shrinking. It's around 16,500 about a few months ago, official numbers. I have a guess, because last 3 to 4 months, about 2,000 front-end engineers, front-end developers were on bench. Because their particular front-end, it was a coding in front-end task, very well replaced by AI agents. So I'm pretty sure our numbers are further shrinking. Same time, our revenue is about 5% growing, but our rest of the cost structures also goes up. Now, this is a software engineering, or the typically, I think the bulk of the students came into companies like us, Virtusa, and all. Now, the problem is, we are seeing is, I'm also questioning is, the reason was it's end of the day, business are happening on the demand and supply, So we are catering in capitalistic models, we are catering demand and supply. So earlier we had a huge demand, lesser supply. Suddenly, because 2023, your intakes could have been less than 100, 150. Suddenly your intakes also moved to about 300, 400. This is the same, right? Same demand supply problem. Every student, every institute. Now suddenly within the verge of this AI and the disruption, 2023, that is, I think, the peak time of students enter into software engineering discipline. That's a peak of payments. It's the same phenomena of any market. And 2020, I can still remember 2023, that's the GPT-3 came up. We had a 10x plans in Dubai, came up in 1 month. We slashed entire game to a different direction. We knew this is going to happen, this is going to disrupt our industry. We want to take a different direction. So at that point onwards, we shrink our people count to about 3,500. It would further shrink to a certain extent. But I think now, after about 2 to 3 years, 4 years, suddenly we may find we need people. And the entire industry, most of the people have moved away. That can be a scenario. This is the same thing, demand and supply. How suppliers finding no one is interested, they are moving away. Then it would be suddenly flipped. So this is a transition time period of this entire equilibrium. So we are yet to figure it out. And I want to tell a very interesting thing. America, right? Companies are, I think, the VC guys, and they are, I think, too greedy on capital things. Not America in the sense of that aspect. They are allowing companies to fully optimize their businesses by eliminating people. But in China, what I heard is, as a policy, they are telling, you cannot send out people just because of AI. It's part of our economy business to repurpose them. The reason is, if after some time, if they don't have the spending power, who is going to buy your products? So this is a huge ripple effect. I think this is a bigger problem. That's why time to time we have to go into fundamentals and ask. So telling you to your students, right, certain things I have to adhere to our investors, we all know. So that's why we started T2T. I think you were traced, right? We were trying at least small scale because I think I had count since 2006. I started internship. I have trained directly under my supervision with my teams more than 1,500 people. Among them, some become the national entrepreneurs. So that was a very, 2023 onwards, we decided not to hire. But we saw this problem. So what we try to do is bring them, keep them with this software engineering knowledge, but making sure they can adapt into this fast changing cycle, right? Every other week, suddenly something is changed, right? With this AI wins. So what I want to tell is, I think this is the time where we all have to get into the basics and make sure our most required skills are there. Only thing is problem solving skills.
So yeah, so Sankalpa also crossed the line. So I'm going to relax that that earlier playing the roles thing. You can just be yourself. But yeah, I'll make the question a bit harder to Srinath. I mean, like, okay, if the graduating student is already able to kind of orchestrate multiple agents, would you hire them?
So the my question is, the fundamental skill is debugging, troubleshooting, right? So I alluded to this earlier. So the basically when you work with AI and when AI creates something and we are building these feedback loops or all these lot of things, because these thinking feedback loops are much faster on AI. So when it is wrong in very complicated way. Right? So your job is to, two things. One thing is to say, okay, maybe I need to check this, right? It is like, it's now you go into like 10,000 feet level, watch, and like smell it, and then when something is wrong, fix it. So I think it will, so that maybe after some time, AI will get better, and the one human may not be able to do that task. It may be a team watching AI, right? So these will happen. We are never taught to like sit down and think of one problem for a long time. That's not the usual model. I mean, if you go to a PhD, they will push you to do it, but not. So I think that mode also has to change, because that like the snapshot decisions, a lot of them AI can do. It is like when things are breaking, etc. But I am. So okay. People who knows me know I was like this even 3-4 years ago, fighting with a lot of people, because I fundamentally believe that world is very complicated to be solved. Like, I don't think we run out of problems. I'll give you an example. So in this science fiction thing, there is a scale of energies, right? So the first, the scale, that's 0. 0 means fire. You can create fire. The scale 1 means you can manage energy at a planet level. That means you can change weather. You can control weather. We are not there. No, we are not there. The next level means you can manage the energy at a star level. Next level means at a like a solar system, the bigger multiple. Okay, now we are ants, right? We are crawlers. So there are so long to go, right? And when people were building the fire, they could not think of the rockets, right? I mean, it is like, if I get 10 times more power, what can I do? There's nothing to do. There's nothing to do like that. And that's how I think we will, I don't think we'll run out of problems, right? But these problems may be hundreds of people working together, taking years, because we'll get into more like more thoughtful, more into a model. So there will be like silicon intelligence and there will be biological intelligence. They have their strength and weakness. They will be working together, but I think there's a role to play and we might merge. I mean, I think the natural conclusion is it will merge.
Okay. Be ready with your questions. But the final thing to know on is, about the industry. So the industry clearly is not hiring. And there are many students here and there are many academics here who have some obligation, even though the idea of education is for intrinsic development, there is an expectation in countries like Sri Lanka for employment. So right now there is a big disillusionment. And so companies obviously are not hiring the kind of people they used to hire, but who will they hire?
So one thing to clarify, so many companies have lowered hiring of new grads, but actually demand for people with about 3 to 5 years of experience actually has gone up. And everyone is trying to hire that type of people. So now we are kind of, maybe we are still maybe a couple of years away where we run out of those senior people. So I think at that time, the market will have to figure out something. So either we will have a situation where industry will realize this and go back to hiring junior people, because without junior people, you're not going to have any senior people. So there's something like that. I think that solution will happen if no other solution happens, but that solution will be quite painful and will also happen probably later than we want it to happen. So I think a better solution is if there is an earlier solution, and probably that is where academia has a part to play, where kind of the curriculum is adapted and maybe not going all the way, but meeting industry kind of somewhere in the middle, where you have not a software engineer quality of sort of 5 years, but maybe somewhere in the middle, and then industry can take them over and go the remaining path. So I think somewhere this adaptation should happen, because the alternative is the market will take care of it, but that will be quite painful.
Okay, so floor is open for questions. Just put your hand up and a mic will come. Yeah.
Hiring. Now, it's important that as undergraduates, you are relevant, right? Because when you put into a curriculum, it's research, it's taken few years, right? So if you take the AI industry, 2-3 weeks is just a couple of years in another industry. So what you're learning is few years ahead. What was there a few years ago, right? So you need to be relevant, and I would really like everybody who wants to get employed, stay relevant in the industrial things going on. Now, I will just explain a recent hire that I did about we wanted to hire somebody about 3-4 years experience at least. But the person who was 15 years of experience, who worked in a very, very prominent company, we didn't hire because he was not relevant in what he was talking about, right? What we hired was, there were 2 shortlisted, now 2 are hired. They were more relevant in their conversation. They knew what was going on. So if you want to be relevant, you really have to, I'm just advising this everywhere I go, have a YouTube channel for local stuff, have a YouTube channel for US and technology, right? Have an X for local stuff, have an X for US and technology. You can't do big smooth, right? The moment you listen to Dherana, you're not going to actually get anything related to technology with that line. Have 2 channels. Completely focus yourself where the technology is, because it's exponentially growing, right? And the opportunities are growing much a faster rate also, as what I was talking about. Like, we would discover, the world will discover more problems, right? But if you're not relevant to solve that problem, you would not be hired. That's the thing. That means that you need to be actually up to date, relevant, find some interesting industries, keep on watching them. And when you go to that company and say, okay, I kind of did a research on your area and I did this sort of thing myself, that's what the hiring will trigger you. I mean, they wouldn't come and, we even organized an event recently about OpenClaw. And half of the people who haven't come even haven't read about OpenClaw, even listened to YouTube, right? So the meaning of the whole event is also gone because of that, right? Some undergraduates come and ask, okay, can I get an internship? Then I ask, did you know about OpenClaw? This event was about OpenClaw. And he said, I haven't even seen or read. I would have expected the person to have experimented on OpenClaw to come and do it, because people can do it, right? There are people who are trying. So relevance is very highly missing in this undergraduate field. You have enough time. Don't say you don't have time, right?
Thank you. Questions? I'm just reminded of when we started the information systems program back at UCSC. One of the things we told students is you need to kind of have an in-depth insight into one domain in your final year. In the previous years, we take them on industry visits and things like that, but by the final year, they should have one in-depth insight into some domain. So I don't know, this is something we can try again. Yeah. Any questions to the panel? Yes.
As academics, we have noticed a significant gap in the skill set that is required from the graduates and what is required from the what the industry is asking for. But there's a huge trend among the current undergraduates. They are using all these agents to get a short-term benefit. That means they just want to pass the assessments. And we have noticed that they are lacking the human skills, what we were keep on listening from the beginning of the session, especially critical thinking and being responsible. So do you have any specific suggestions or recommendations to the academics on training the current undergraduates, how they can how we can train them to get acquire these skill sets rather than just using the agents to get short-term benefits just to pass the assessments?
So to add to that, I mean, I think for, I don't know, probably a century, we use standardized testing as the way, and that is like using the final product as a proxy for learning. But it turns out that now it's no longer a good proxy for the learning process.
Yeah, I think that's a challenge what you asked, right? The problem is we are leaving room, right? For example, we are still doing the same sort of assessment, right? We may ask, okay, to test a student, good old days, okay, why don't you read few books and then comprehend all these things and give us a report, maybe as a team. If we didn't have computer or anything, it is a huge mind exercise, right? Massive brain. Once you do that, right, you have to go to a library, read catalogs to transfer, all these things. Now, after about say 2 to 3 weeks or 4 weeks of that discovery phase, he or she, her mindset totally different. But still we are given the same problem in today's context, where everything is digitized, translations are happening, and search engines are there. And on top of that, now comprehension, put them together and giving their opinion. Now people are not even giving opinion. Now question is, we are still assessing them. We are putting the question, but they are given a wrong set of tools. So I think we need to now once again go back to our old drawing room of teaching and figure it out. Okay, let's redefine these certain things. For example, until recently, I was thinking, right, until generative, I was thinking, okay, our Sri Lankan students were too much, I think, memorizing, right? But now suddenly I found we are not encouraging at all. Now that was a big issue, because end of the day, we need to have people who can orchestrate agents, right? They also have to have that certain amount of memory. Without that memory, it's not possible. So I think we all, as whatever the education, especially, we have to get to our drawing board and figure it out certain things. End of the day, what's the purpose of education? To build knowledge and skills, right? We call the Shilpa Shastra. But what we have actually done. So it will be another 1 hour chat, right? I find.
Yeah.
So, but let's get to I think our fundamentals and try to challenge the way we are educating. I know it is a transition time period. We also cannot do a lot of things because some of the accreditation bodies, they are not ready yet. So it will take about another 5 to 6 years. This is what's happening. But same time, we all know this is the new generations are the ones they claim their intelligence has started to diminish. Still we haven't seen the intelligence diminishing because of agentic things. This is because of the, I think, mobile phones or the mobile social media, so which was about 10 years effect. Yet to see the agentic, it may suddenly drastically drop our intelligence, human intelligence. So we may have to, these are the real challenges.
Yeah, I'm conscious of the time and we should have lunch at 2 o'clock. So we'll get on to some other questions, give some, and
I'll add a little bit to that. So one comment is, even before you go and find a senior, so even in school also, when you given a big book to read, you go and find last year's senior. So, I mean, but two quick comments. So one thing is, instead of the report, you can ask for the prompt. You can ask everybody to give the prompt, and then you can run the prompts and compare the results. So if you haven't thought much, it'll kind of average, but so that's this one. Second thing is, you can build like role-playing tests. I mean, if they have understand, they can only pass, right? So you are given a scenario, like you're given a problem, but you can get to make the AI make the role play. So you have to win that scenario. So that is the assignment. So like that. So we have to flip it. I think there are a lot of work happening, and yeah.
Questions? Yeah. Up here.
Yeah, at this point I have already identified everyone's role, so I will be taking the Srinath's role here when asking the question. So, so most of the time in Sri Lanka, that the middle range companies, like 200 to 300 range companies, still struggling to adapt to digital systems. So actually, at this point, the large enterprises that has more than 300 employees are actually having the problems that cannot be solved without a digital transformation. But when it comes to the middle range company, so me and my co-founder, we had a case study that we did. Was actually, we thought about this, and we went to a company, and then we stayed there for 3 months, and then we figured out what are the problems that they are actually not going for a digital transformation. So the one thing is, they do have some sort of anxiety because they will not stay a middle range company for a very long time. They will anyway going to become a large range, large scale company. So then if we do adapt a vibe coded system, okay, so then what are the chances that the middle range companies in Sri Lanka actually do have some sort of anxiety to get into the digital transformation? And then what are the chances that it could, that the anxiety problem that they are having become real if we go on with these vibe coded systems? Okay.
Akashani is always a bit complex, but
observation, especially with AI. Now, we used to be having managers who are asking people to do stuff for them, and even for AI, I'm assuming most of the leadership ask their level below to do research and tell them stuff, right? Now, adoption is so fast. Now, actually, you need people in the management tier and even in the CEO level to be nerds.
to be going down in the technology path, discovering themselves things, and figuring out themselves how to solve these issues, right? Then the transformation will pull. Because as long as you ask level below, whole company operates in a expertise that are in the layer below, but the company has to actually take it up in a leadership level. Leadership level people has to become more nerdy. Now, if you take, for example, Dulit Kapruka, right? He has deployed a lot of technology on his own into the distribution chain as well as in his other businesses because he himself has gone into learning technology, right? Technology is going to solve a lot of the company's issues, but until that management level leave their board seats and take on technology into their hand, this transformation wouldn't take off, because that is what we are seeing. Even in large companies in US, if the leadership is nerdy or go into technology, they will do the transformation. Otherwise, if you let consultants do your thing, rely on consultants, because you'll be paying a lot. I mean, if you hire McKinsey, the Indians will come and do a research and they thumping consultant, it won't do, right? You have to take on that responsibility yourself. If you are actually working with small companies, encourage them to do that, because otherwise this is not going to go. And the problem that we have in our society, how the society works is that if you have like 10 people reporting to you, 50 people reporting to you, you're the top guy, but if you're an expert in a certain area, you're not the top guy, right? It can't be the case. You have to be an expert in your own domain area, and that is the respect that should be getting for, not because you have 10 people reporting to you. Right? 10 people reporting to you will actually benefit if you are also an expert in that area. If you are an expert in that area, those 10 people will benefit. But if you are just a people person, like saying nice things, encouraging things, and doing pep talk, that's not enough for the technology transformation.
Okay, so we are going to bring this to a close, and by asking each panelist to say their last piece in one sentence. I didn't warn them about this. But yeah, because time kind of went very fast, and I realize it's time for lunch. In one sentence, who wants to go first? You can decide who wants to go first.
Okay, very simply, what my advice is, I think it's a high time for us to go into fundamentals and really see through what's happening. Then I think we can get out of frustration and figure it out, new pathways to come out.
Thank you. Okay, so the AI is very capable, but it is still a tool. So it is basically we cannot forego the responsibility. We have to own and make sure it does what it's supposed to do. Rukshan.
Sri Lanka lost many waves. Don't lose this one.
Thank you. And finally, Nuwan.
So it's not that I'm kind of purposely trying to kind of end on a kind of a positive on a positive note, but I think this is positive, which is I think we did discuss a lot of the negatives to do with AI, but the kind of the reality is that there are a lot of positives. So one thing that I kind of tells the startups that I work with is like, there's no time like this to go and solve problems. You have so many tools to solve problems. And so I think rather than worrying about the things that people tell you to worry about, you should just go out there, find a problem that you're really interested in, and just solve that. This is the best time to do that. Yep.
Thank you very much, and thank you to all the panel members for making time and coming. I know you are very busy people. Thank you.
Thank you. Dr. Veera Singh, dear panelists, could you please remain on stage? Dear panelists, could you please remain on stage? And now, a moment to recognize the people who made today what it was. We'll start by presenting our tokens of appreciation to our panelists. I invite Dr. Ruwan Veerasinghe to do the honors. Mr. Nuwan Senaratne. Dr. Srinath Pereira. Dr. Sankalpa Gammangi. Mr. Rukshan Jayaratne. Dr. Veerasinghe, please do remain in stage, and Dr. Tilak as well. We now move to our certificate distribution, recognizing the presenters and contributors who gave their time and expertise to make today possible. Mr. Samudra Kanake Arachi, Director of AI and Research at 99X. Mr. Isru Disanayake, EVS Group. On his behalf, I would like to invite Bhuendra Abe Surya to collect the certificate. Mr. Anusha Samarakkodi, Associate Tech Lead, Dialog Asiata PLC. Mr. Joseph Fonseca, Vice President and Distinguished Engineer, WSO2. Mr. Praveen Dhananjay, Senior AI Engineer, Synopsys. Mr. Asir Samaravira from Dialog Asiata PLC. Mr. Bhuendra Abe Surya from EVS Group. Mr. Janit Pitanagamage from EVS Group. Ms. Ayesha Sanjeevani from Synopsys. Mr. Mohan Narangoda from Dialog Asiata PLC. Mr. Theomika Silva from Dialog Asiata PLC. Thank you, Dr. Ruwan. Thank you, Dr. Tilak. Before we wrap up, we'd love to hear your thoughts on today. There's a feedback form available via QR that's being displayed now. It'll only take a minute. It genuinely helps us to make the next conclave even better. Please do take a moment to fill it in. In any case, the QR isn't working, we'll email you the form. To formally close today's proceedings, please welcome the Associate Dean of Research at Informatics Institute of Technology, a computer scientist and educator with over 12 years of experience in teaching, research, and academic administration, holding a PhD in computer science from University of iCIIT, Japan, and a passion for advancing the next generation of scholars and professionals. Dr. Tilak Charminder. Dr.
Thank you. Members of the management of iIIT, distinguished guests, academic heads, keynote speaker, panel members, researchers, industry partners, and students. On behalf of the Research and Innovation Unit and Organizing Committee, it's my privilege to deliver the vote of thanks and express our sincere conclave. First, I would like to thank the management of iIIT and all academic heads for their leadership, guidance, and continuous support in making this event possible. Our sincere appreciation goes to our keynote speaker, Mr. Nuwan Senaratne, for his inspiring address and valuable insights. We also thank our distinguished panel members, speakers, and presenters for generously sharing their expertise, experience, and research with us. We gratefully acknowledge our endorsing and supporting organizations, SLASCOM, iSACA Sri Lanka chapter, CSSL, and BCS Sri Lanka for their valuable partnership and support. A special thank you goes to all researchers, delegates, participants, and industry partners whose active engagement made this conclave meaningful and productive. We also extend our appreciation to the marketing, administration, IT, accounts, and media unit, and all academic and administrative teams for their dedication and teamwork in ensuring the smooth execution of the event. Finally, I would like to express my heartfelt gratitude to the organizing committee of the Research and Innovation Unit. Their commitment, professionalism, and tireless efforts behind the scenes were instrumental in making this conclave a success. As Associate Dean, I am truly proud of their achievements and grateful for their hard work. Before I conclude, I would like to extend my sincere appreciation to Dr. Ruwan Weerasinghe for his visionary leadership, unwavering support, and commitment to advancing research, innovation, and academic excellence at iIIT. Thank you for your participation, support, and contributions. We hope the knowledge shared, connections built, and collaborations initiated today will continue to inspire future research and innovation. We look forward to welcome you again at the future editions of iCIIT. Thank you.
Thank you, Dr. Tilak. And with that, iCIIT Conclave 2026 is officially a wrap. We started today's event with a pretty heavy question. How do we build AI systems that are actually reliable and ready for the real world? After industry presentations, a keynote, and a panel discussion, I think we got some genuinely practical solutions and potential future gaps today. But let's not stop it here. The conversations you had today, the ideas you picked up, take them back to your teams, your labs, your projects, and beyond that, take them out into the world. Sri Lanka has the talent and the thinking to be part of this global conversation. And days like today are proof of that. So keep pushing. A huge thank you to our speakers and panelists. You gave us your time, your expertise, and your real-world insight. That's not something we take for granted. And I also want to thank our endorsers, SLASCOM, the Sri Lankan Association for Software Services Companies, BCS, the Chartered Institute for IT Sri Lanka, iSACA, the Information System Audit and Control Association, CSSL, the Computer Society of Sri Lanka, for their continued backing for giving this event the reach it deserved. To iIIT Research and Innovation Unit, 7 years of putting this together, congratulations on another one. And to all of you, thank you for showing up, staying engaged. It's a fast-moving field, and it is good to know the right people are paying attention. It's been a privilege. Hosting you today, I'm Quinn. Thank you. A small note, so before you head out, lunch is being served on the 8th floor, so which is 1 floor up. Please do head up, join us, and enjoy the rest of your afternoon. Thank you.